Very easy question, highly repeated question, high frequency question. So first we will read the question again and again. Thumb rule. What we will do is we will spend a lot of time in reading the question, understanding the concept, finding the root cause of the problem, solving it from the root cause angle only. What we will do is, for me, every time I read the question twice. When I read the question first, I will understand what is that input that is given in the question and what is that output that is expected from the given inputs. Please read the question first. How many positive 3-digit integers? When I say a positive integer, it is called a natural number. It is called a natural number. Integers are of 3 types: non-negative integers, positive integers, and 0. 0 is the beginning element of the set of whole numbers. When I say non-negative, other than the negative, it will be 0 and positive. Then we have got positive integers. Positive integers are called natural numbers. 0 with positive integers are called whole numbers. So anybody ask non-negative integers, first write down that point. When anybody in the question gives non-negative integers, integers are of 3 types: negative, 0, and positive. Non-negative means other than negative. What is there? 0 and positive. Non-negative integers, another synonym is, it is a whole number set. Non-negative integer, another synonym is, it is a whole number set. Positive integers which are positive. Integers which are positive are called countable numbers. What are the numbers that can be counted? They are called natural numbers. In examination, if anybody asks natural numbers, it is as equivalent to finding positive integers. If anybody asks whole numbers, it is finding non-negative integers. First statement, it is clear to me. I will break the question into sub-questions. I will go one by one. Now question. What is the question? How many positive 3-digit integers are there? How many means it is a counting problem. How many means it is a counting problem. Unless and until I know counting problems very easily and I am very, very fast in counting, I will never solve counting problems in innings 1. Innings 1 are the questions which can be solved in less time and less number of steps. Counting, you consider yourself very good in counting and calculation, then go ahead and solve this kind of questions. This will eat little time. How many positive 3-digit integers are there? Have a remainder of 2 when divided by 6. We do not know how many numbers are there. So there are some numbers. Let me call it as n. These when divided by 6, it is giving a remainder 2. A number when divided by 6, it is giving a remainder 2. And it is giving a remainder 5 when divided by 9. The same number when divided by 9, it gives a remainder 5. The same number when divided by 11. It gives a remainder 7. First, I will tell you a very straightforward way of solving a question. This is a most highly repeated model when a number is divided by multiple numbers. First, I will tell you direct answer, then I will tell you how that answer is derived. So that then I will probably give you some practice questions in the class where you will do it. Now, if you see here, there is a number, it is divided by 6, 9, and 11. There is a number, it is divided by 6, 9, and 11. Positive reminders are 2, 5, and 7. 2, 5, and 7. So first I will tell you a non-mathematical way, then I will tell you a mathematical way. So for that I require a slide. Let me take a slide. Number when divided by. If you see what is the question, it is divided by 6, 9, and 11. Number when divided by 6, 9, and 11. Positive reminders are 2, 5 and 7. Very easy question. 2, 5 and 7. First is traditional method, then I will tell you the optimal method. Optimal method is derived from traditional method. Optimal method is a method which reduces the number of steps to solve a problem. Every optimal method has been derived from traditional method. You solve a problem 10 times 10 different ways, you will come to know what is the optimal method. That's how most of the teachers will teach the so-called shortcut. Shortcut is nothing but an concept derived from the traditional method. Traditional method. Number when divided by 6, there is a number. This number is getting divided, so this is called the dividend. A number is getting divided by 6. This number is getting divided by which number? 6. 6 is called a divisor. I do not know the quotient A, but I know definitely that remainder it is 2. Remainder it is 2. First step, I hope it is clear. The same number when divided by 9, quotient I don't know, remainder it is 5. The same number when divided by 11, quotient I don't know, but the remainder it is 7. I hope the idea it is clear. Any doubts are there in any of these logics? Kindly ask me. Any doubts are there? No. There is the same number. Same number is divided by 6 with a remainder 2. Same number divided by 9, remainder 5. Same number divided by 11, remainder 7. Now, we know division theorem. Dividend equivalent to divisor into quotient plus remainder. Dividend is n. Dividend equivalent to divisor into quotient plus remainder. Quotient plus remainder. In case if you are from non-max background, suppose if I divide 9 by 4, 4 2s are 8, remainder 1. Dividend equivalent to divisor into quotient plus remainder. 9 is 4 into 2 plus 1. 9 is 4 into 2 plus 1. So n is 6 into a plus 2. N is 9 into b plus 5. Same n is 9 into b plus 5. Listen very carefully, sir. Same n is 11 into c plus 7. 11 into c plus 7. Listen carefully. So 6 into a plus 2 it is. I wrote it as 5. So here it is 2. 6a plus 2, 9b plus 5, 11c plus 7. Small little change which I do it, I will get the answer. Suppose what I will do is, I will add 4 and I will subtract 4. I want to make this value equivalent to the coefficient of a. What is the coefficient of b? 9. I got 5. I will add 4 and I will subtract 4. What is the coefficient of C? 11. I will add 4 and I will subtract 4. So the entire equation, I am making some addition and subtraction. Why am I doing that? In the next step you will come to know. So 6a plus 2, coefficient of a, it is 6. So I am adding 4 and I am subtracting 4. Coefficient of b, it is 5. I am adding 4 and I am subtracting 4. Coefficient of c is 11. I am adding 4, I am subtracting 4. Sir, what will happen if you do like that? Then you will come to know n equivalent to 6a plus 2 plus 4. This will become 6 into a plus 1 minus 4. Are you all with me? So this will become n equivalent to 5 plus 4, 9. 9 into b plus 1 minus 4. N equivalent to 11 into c plus 1 minus 4. So minus 4 goes to the left hand side, n plus 4. N plus 4 is equivalent to 6 into a plus 1, 9 into b plus 1, 11 into c plus 1. So n plus 4 is equivalent to 6 into a plus 1 or 9 into b plus 1 or 11 into c plus 1. Now if you see 6 into any number, that means it is divisible by 6. 9 into any number, it is divisible by 9. 11 into any number, it is divisible by 11. Right hand side is divisible by 6, 9 and 11. Right hand side is divisible by 6, 9 and 11. What is the number which is divisible by 2 and 3? LCM of 2 and 3. What is the number which is divisible by 3, 4, 5? LCM of 3, 4, 5. What is the number that is divisible by 6, 9 and 11, which is LCM of 6, 9 and 11. LCM of 6, 9 and 11. Are you all with me? I hope till here it is clear. Till here it is clear. Very simple, non-mathematical way. So this will become, I'll use a different color. This will become n plus 4 is equivalent to LCM of 6, 9 and 11. 6 and 9. What is the LCM of 6 and 9? 9 is not divisible by 6. Next multiple it is 18. 18 is divisible by 6. LCM of 6 and 9 is 18. 18 and 11 are co-prime to each other. LCM of co-primes is their product. So it is 198. So answer will be a multiple of 198. So n plus 4 will be 198. 3-digit number is asking into 1, into 2, into 3, into 4, into 5. Into 5. 200 into 5 is 1000. So 198 into 5, it is 990. 990 minus 4 is 986. So how many 3-digit numbers we got? That many values K takes, that many numbers we got. K can take from 1, 2, 3, 4, 5. K can take from 1, 2, 3, 4, 5. So K takes from 1, 2, 3, 4, 5. How many value 3-digit numbers are possible? 5. Very simple, non-mathematic way of looking at the question. Non-mathematic way of looking at the question. I hope the idea it is clear. Equations it is clear. What is the concept I used here? The concepts which are used to solve these problem is dividend equivalent to divisor into quotient plus remainder. Dividend equivalent to divisor into quotient plus remainder. I got 3 equations. One it is giving remainder to another 5, another 7. I want to make it same. How to make it same? Coefficient of A it is 6. So I added 4, subtracted 4. Coefficient of B is 9. Added 4, subtracted 4. Coefficient of C is 11. Added 4, subtracted 4. This in our mathematics textbook, minus 4, minus 4, minus 4. Put a star mark. Put a star mark. You don't need to do all this. Minus 4, minus 4, minus 4. Positive remainder it is 2. Negative remainder it is minus 4. Are you all with me? Positive remainder 5. 5. 9 ones are 9. So 5 is 4 less than 9. 11 ones are 11. It is 4 less than. So n equivalent to LCM of, this is the direct answer, a mathematical way of writing it. LCM of 6, 7, 9, 11 into K minus 4. How you got minus 4? 6 ones are 6. 6 ones are 6. From 6 if I subtract 4, I will get the answer 2. So therefore minus 4. 9 ones are 9. From 9 I need to subtract 4 to get 5. 11 ones are 11. From 11 I need to subtract 4 to get 4. So LCM of 6, 9, 11 into K minus 4. I hope the idea it is clear. So this is a classic case where the negative reminders are same. This is the classic case where the negative reminders are same. Let me do one more question. Listen carefully. If you follow the equation method, you will get a very good understanding of when the positive reminders are same, when the negative reminders are same. Case by case I will solve. Case number 1. Case number 1. A number when divided by 7 and 9. A number when divided by 7 and 9. Positive reminders are 2. Positive reminders are 2. Number when divided by 7 and 9, positive reminders are 2. Positive remainder it is same. If the positive remainder if it is same, so this is called n. Number is first divided by 7, remainder 2. Number is divided by 9, remainder 2. So if it goes to the left hand side, n minus 2 is equivalent to number divided by 7 and 9. So it is LCM of 7 and 9 into k. So n equivalent to LCM of 7 and 9 into k plus 2. Depending upon the value of k, I will get a 2 digits, 3 digits, 4 digits, so on and so forth. This is the case number 1 where the positive remainders are same. This is case number 1 where the positive remainders are same. Case number 2. Case number 2. A number is divided by 7, 8 and 9. Positive remainders are 1, 2 and 3. Positive remainders are 1, 2 and 3. The shortcut is derived from this equation method only. The shortcut is derived from this equation method. Number is divided by 7, 8 and 9. Positive remainders are 1, 2 and 3. So number when divided by 7, positive remainder 1. Number when divided by 8, positive remainder 2. Number when divided by 9, positive remainder 3. Are here in case number 1, positive remainders are same. But in case number 2, positive remainders are not same. Check it out. What is the coefficient of A? 7. I got 1. So add 6 and subtract 6. Coefficient of B, it is 8. So add 6 and subtract 6. Coefficient of C, it is different quotients. Coefficient of C, so this will be 9C plus 3. Coefficient of C, it is 9. So add 6 and subtract 6. If you observe, these entirely divisible by 7, entirely divisible by 8, entirely divisible by 9. So n plus 6 is equivalent to LCM of 7, 8, 9 and k. Depending upon the question, we will substitute the necessary values, 2-digit numbers, 3-digit numbers, 4-digit number, maximum 2-digit number, minimum 3-digit number. Any question can be solved by using the values of k. Case number 1, positive reminders. Case number 2, negative reminders are same. Case number 3. Case number 3. Total 4 cases are there. When a number is divided by multiple numbers, positive remainder can be same. Now see here. A number is divided by 7, 8, 9. Positive reminders are 2, 4 and 6. 2, 4 and 6. Very interesting question it is. Number is divided by 7, 8 and 9. Positive reminders are 2, 4 and 6. Now listen carefully. So number when divided by 7, it is 2. Number when divided by 8, it is 4. Number when divided by 9, it is 6. It is 6. Listen carefully, sir. What am I doing? Now if you see here, coefficient of A, it is 7. So it is plus 5 minus 5. Coefficient of B, it is 8. It is plus 4 minus 4. Coefficient of C, it is 9. So it is plus 3 minus 3. It is plus 3 minus 3. So here it will become n equivalent to 7a plus 2 plus 5. It is divisible by 7. So 7k1 minus 5. n equivalent to 4 plus 4, 8. 8 plus 8b. 8k2 minus 4. 6 plus 3, 9. n equivalent to 9k3 minus 3. 9k3 minus 3. Here all the cases I got the negative remainder same. It is different. So go to the next step. What is the coefficient of k1? 7. So I require 7. So if I require 7, it is plus 12 and minus 12. Coefficient of k2, it is 4. So it is plus 12 and minus 12. Coefficient of k3, it is 9. So it is plus 12 and minus 12. Are you all with me? Are you all with me? Very simple way of understanding this question. So if I see here, now if you observe, 12 minus 5, 7. So this I am writing it here. I will use a different color. I hope you are understanding. No need to remember anything. 12 minus 5, 7. 7 into k1 plus 1. So this will become 7x minus 12. So this will become 12 minus 4, 8. This will become 8y minus 12. 12 minus 3, 9. This will become 9z minus 12. So the number will become LCM of 7, 8 and 9 into k minus 12. I hope the idea it is clear. Case number 1, we have to keep on doing it till we get a negative remainder same. Either it will result in a negative remainder same or it will not result. If it does not result, how to solve? That also we will see. Case number 1, where the positive remainders are same. Case number 2, how the negative remainders are same. So if you see here 1, 2 and 3, difference is 1. In one step itself we got the negative remainder same. 7, 8, 9, 2, 4, 6. 2, 4, 6. Difference it is 2. So in the second step of negative remainder I got it same. Second step of negative remainder I got it same. So n equivalent to LCM of 7, 8, 9 into k minus 12. Case 1, case 2, case 3. I hope the idea it is clear. Positive reminders are same. Negative reminders are same. In some steps negative reminders are same. There is another case. Case number 4. A number when divided by 7, positive remainder, it is 1. A number when divided by 9, remainder, it is 0. Remainder, it is 0. A number when divided by 7, positive remainder it is 1. A number when divided by 9, it is perfectly divisible. Question is, what is the smallest 3-digit number n can take? What is the smallest 3-digit number n can take? This is the question. What is the smallest 3-digit number n can take? Now, if you observe here, are the positive remainder same? No. Are the negative remainder 1 minus 7 minus 6, 0 minus 9 minus 9? Negative reminders are also not coming. Case number 4. Case 1, when the positive reminders are same. Case 2, in one step negative reminders are same. Case 3, in some steps negative reminders are same. In case number 4. A number when divided by 7, remainder it is 1. So it is 7a plus 1. A number when divided by, dividend equivalent to divisor into quotient plus remainder. A number when divided by 9, perfectly divisible. Perfectly divisible. So this will be equivalent to 7a plus 1 is equivalent to 9b. 7a is equivalent to 7b plus 2b minus 1. 7b plus 2b minus 1. Is it clear? I hope till it is clear. This is divisible by 7. 7a is divisible by 7. This is also divisible by 7. That means 2b minus 1. If I call it as one term, it should be divisible by 7. If it is divisible by 7, so 2b minus 1 can take either 7 or 14 or 21 and so on. 2b minus 1, 7. So b minimum value, it will be 4. b minimum value, it will be 4. b minimum value, it will be 4. Next one, 2b minus 1, 21. b value will be 22 by 2, 11. 22 by 2, 11. And so on and so forth. Sir, can I take b value 11? That will be the repeated numbers. So b minimum it is 4. b minimum 4 means the lowest number is 36. Every time the number is divisible by 7 and 9. So answer will be 36 plus LCM of 7 and k. 36 plus LCM of 7 and k. I hope it is clear. If you observe carefully, b value 11 we got. b value 11 means if you observe 7 comma 9 into 1 763 plus 36, it is 99. b value 11 means 9 into 11, it is 99. So that means this entire series follows the pattern 36 plus LCM of 7 and 9 into k. 36 plus LCM of 7 and 9 into k. Smallest 3-digit number. 36 is one number. K value 1. 63 plus 36, 99. Largest 2-digit number. I want the smallest 3-digit number. That means K value 3. So 36 plus 63 into 3. 63 into 3, 189 plus 36. 9 plus 6, 15. Answer unit digit should be right 5. Anything other than 5, please eliminate it. Do not get into too many of calculation. 189 plus 36 is 225. 189 plus 36 is 225. I hope this concept is clear. What are the cases that we discussed? 4 cases that we discussed. What is the first case? Positive reminders are same. What is the case number 2? Negative reminders are same. Case number 3. Here in 2 steps the negative reminder it is same. 2 steps means 2, 4 and 6. Difference is 2. 2 is 2 times 1. So in the second step of negative reminder I will get the answer. Second step of negative reminder. Neither the positive reminders nor the negative reminders are same. Neither the positive nor the negative reminders are same. First question, I hope complete clarity you got in solving this problem. I hope it is perfectly clear. Any doubts are there? So I think there are no doubts. So first one, it is clear. Now let me discuss another good question. Okay, let us see this question. Prove that there does not exist any positive integer. First thing, thumb rule, don't forget, read the question twice. Prove that there does not exist any positive integer n less than 2310. He is telling, prove that in this question n is a natural number. N is a natural number. Natural number is less than 2310. Any natural number less than 2310 is not possible which satisfies this equation. What is the equation? N into 2310 minus n. It is a multiple of 2310. Any multiple of, what are the 4 multiples? 4 2s are 8, 4 3s are 12, 4 4s are 16, 4 5s are 20. So any multiple of 2310, it is written as 2310 into k. What is K? K represents the multiple of 2310. K represents the multiple of 2310. I hope it is clear. Again, I will repeat the question for you. He is telling, prove that any natural number n is taking less than 2310 will not satisfy this equation. What is the equation? N into 2310 minus n. This number should be a multiple of 2310. Multiple of 4 is 4 2s are 8, 4 3s are 12, 4 4s are 16. Any multiple of 2310, it is 2310 into k. It is clear, right? Question statement, it is clear. Now see, I see 2310 on the left hand side. I see 2310 on the right hand side. So let me open this bracket. 2310n minus n square equivalent to 2310 into k. So this will become 2310 if I take common. N minus k is equivalent to n square. N minus k is equivalent to n square. It is clearly visible to me that 2310, it is an even number. Let me factorize this number. 2 into 2 11s are 22. 11. 2 5s are 10. 5. So this will become 2 11s are 22. 11. 2 5s are 10. 5. So again, if I factorize it, 2 into 5. 5 2s are 10. 5 into 231. 231. Sum of odd places, it is 3. 3 minus 3. So this will become 2 into 5. 11 into 21. 21, it is 3 into 7. So 2 into 3 into 5 into 7 into 11. 2 into 3 into 5 into 7 into 11. These you will unnecessarily do these factors if you do not read the question properly. You will spend 1 minute in doing something which probably will not help us in getting the answer very fast. If I am reading the question, 2310 is there on the left hand side. It is n square, it is a perfect square. N square, it is a perfect square. Only, first of all, 2310 is not a perfect square. Perfect square always ends with even number of zeros. That means only one number is present here. 2310, only one is present here. And right hand side is a perfect square. That means n minus k. N minus k, another 2310 should be present, and perfect square into perfect square can only give a perfect square. So this has to be a square. 2310 a square. Is this step clear from this? If it is clear, then you will get the answer. 2310 is already present. In bracket, another 2310 should be present. Because it is a perfect square, one more perfect square should be present. So n is 2310 a square plus k. 2310 a square plus k. That means the value of n which satisfies this equation is of the form 2310 a square plus k. K is a positive value. If you add a positive value to 2310, 23 a square is again the square function, it is always greater than 0. This is greater than 0 and this is greater than 0. So greater than 0 plus 2310. Yes, definitely it exists a solution for n value greater than 2310. There exists a solution for n value greater than 2310. That means the values n will satisfy for this equation should be greater than 2310. But we have to prove that n less than 2310, no solution. If n greater than 2310, definitely there is a solution. That means that n less than 2310, there exists no solution. Very simple observational question. Any student who understands the basic property of perfect square, he should be able to solve this question. Sixth is a very, very good question. Seventh question. This is actually a negation based questions. Sixth question is prove that no n value less than 2310 does not satisfy the equation. Similarly, this is another question. Please read the question. Show that there is no integer a such that a will not take any integer such that a square minus 3a minus 19 is divisible by 289. A square minus 3a minus 19 is divisible by 289. There is a will not take any integer. Generally, we are solving the question. How many values a will take such that this equation is satisfied? This is a very good question where we are telling that a no integer it can take which satisfies this equation. A will not take any integer. Good question. A will not take any integer which satisfies this equation. Now see here. Immediately, what is 289? 289 is a composite number which can be written as 17 square. 289 is a composite number which can be written as 17 square. It is 17. Here the coefficient of 3, it is 3. A3. What are the factors of 17? 17 can be written as 10 plus 7. 17. 10 minus 7, it is 3. That idea you should get. That means this can be written as a square minus 10a plus 7a minus 19. So this can be written as a into a minus 10 plus 7 into a minus 10 minus 70 plus 51. minus 70 plus 51, it is minus 19. Minus 70 plus 51, it is minus 19. I hope it is clear. There is a reason why I am writing like this. Very, very good learning from this question. A minus 2 into a plus 7 plus 51. These entire equation can be written as a minus 10 into a plus 7 plus 51. Listen very carefully, sir. Very, very carefully. A minus 10, a plus 7 plus 51. Very, very good learning from this question. Now, if you see here, what is the difference between a minus 10 and a plus 7? It is 17. What is the difference between 2 and 3? 3 minus 2 or 2 minus 3. So difference, positive difference, it is a plus 7 minus of a minus 10. That means difference is 17. That means if a minus 10 is divisible by 17, if a minus 10 is divisible by 17, the difference is 17. That means a plus 7 also is divisible by 17. How it is? Let me take an example, then I will tell you. The difference is 17. That means if this number is divisible by 17, obviously difference is 17. This number will also be divisible by 17. For example, if I take a minus 10 is divisible by 17, a minus 10 is 17. That means a is 27. If this is a minus 10, it is 17. A is 27. 27 plus 7, 34. 34 is also divisible by 17. Are you all with me? If this is divisible by 17, this will also be divisible by 17. Are you all with me? Right? Or in other words, a plus 7 is the negative difference of a minus 10. 17, a minus 10 is divisible by 17. 17 ones are 17. How much it has to go down? It is minus of a plus 7. From 17 to 10 I should come. 7 decrease, a decrease. I hope it is clear. Or what we will do is, suppose for example, a plus 7, let me take 34. If a plus 7 is 34, a value will become 27. If this is divisible by 17, if this is divisible by 17, if this is divisible by 17, multiple of 17, it is 34. 27 minus 10, 17. Right? Very, very important concepts. Extremely important concept. See here. A minus 1 into a plus 4. A plus 4. A plus 4 plus 36. A minus 1 into a plus 4 plus 36 divided by 25. Divided by 25. Same question, sir. Cat replica question. There is a longer equation method. I am not interested in discussing very long method. A minus 1, a plus 4 plus 36. Listen carefully. What is these difference? Difference, it is 5. Difference, it is 5. Are you all with me? If a difference is 5, if a minus 1 is divisible by 5, a minus 1, 5, a value will become 6. What is 6 plus 4? 10. 10 is again divisible by 5. If a plus 4 is 25, a plus 4 is 15, for example. A plus 4 is 15. 15 is divisible by 5. A will become 11. 11 minus 1, 10. 10 is also divisible by 5. If this is divisible by 5, this will also be divisible by 5. That means this entire number is divisible by 25. If this is divisible by 5, this will also be divisible by 5. This is divisible by 25. 36 is it divisible by 25? It gives a remainder 11. So answer is A cannot take any natural number values. A cannot take any natural number values. Is the idea clear? One is to substitute some values. Substitute A equivalent to 3. 3 minus 1, 2. 3 plus 4, 7. Plus 36. plus 36. A value, if I take A value 3, A value 3 means 3 minus 1, 2. 3 plus 4, 7. 3 plus 4, 7. So 2 into 7. 2 into 7 is 14. 14 plus 36. 14 plus 36, it is 50. 50 means for A value 3. For A value 3. It is satisfying. For A value 3, it is satisfying. I hope the idea it is clear. Similarly, if I keep, for example, if I keep A value 3, right? Next one, if I keep A value 5, 5 minus 1, 4, 5 plus 4, 9, plus 36, 4 into 9, plus 36, 36 plus 36, 72. 72 is not divisible by 5. Now, if you observe question here, show that there exists no integer a such that this is divisible by 289. If a minus 20, if this is divisible by 17, this will also be divisible by 17. That means this entire number is divisible by 289. Is 51 divisible by 289? No. So for this question, answer is no integer a will take. Answer is no integer a takes. No integer a takes. I hope the idea it is clear. No integer a will take. Show that there is no positive integer a will take. This is a positive value. That means a minus 10 into a plus 7. This is a positive value. Positive means a is lesser than lesser value or a is greater than greater value. A is less than 10 or a is greater than 10. Under these cases, it will be a positive value. Under these cases, it is a positive value. Obviously, if it is 51, this entire value, it has to be 237 plus something. 237, it is greater than 0. A less than 7 or a greater than 10. A less than 7 or a greater than 10. So instead of doing that long algebraic equation, if this is divisible by 17, this will also be divisible by 17. 17 17s are 289. 289, this part it is divisible. This part 51, it is not divisible. I hope the idea it is clear. I hope the idea it is clear. A is greater than 10. So A value, if I keep 11, 11 minus 10, 11 minus 10 is 1, 11 plus 7 is 18, 18 plus 51, 69, not possible. A is 12, 12 minus 10, 2. 12 plus 7, 19. 19 into 2, 38. 38 plus 51. Like that we have to keep on enumerating such cases. Like that we have to keep on enumerating such cases. I hope the idea it is clear. So a minus 1 into a plus 4. Let me take a smaller value. I took 36 here. Let me take plus 12 because it is not in a simplified form. 36 can again be divisible by 25. So here plus 7. A minus 1 into a plus 4. So that is the reason we got a value. Let us take the equation in a simplest form. A plus 4, if it is 15, a is 11. Two examples, example 1 and example 2. Now you will understand. A minus 1 into a plus 4 plus 7, it should be, right, divided by 25. When it will be divided by 25? When this entire value, it is minus 7 or it gives a number 18. Next 50, 50 means 43. That means a minus 1 into a plus 4, it can either be minus 7 or it can be greater than 0. Remaining all are greater than 0. So this will become a square plus 3a minus 4 equivalent to minus 7. A square plus 3a plus 3 is equivalent to 0. Discriminant is less than 0. Not possible. Discriminant less than 0 means roots are imaginary. So here it is a plus 1 into a plus 4, if it is greater than 0, that means a is less than lesser value, or a is a minus 1, right? Okay. I hope the idea it is clear. Just I don't want to do algebraic method. A minus 1 into a plus 4, it is greater than 0. A less than minus 4 or a greater than 1. Like that we have to do. Idea is not to tell you this method, but I wanted to tell you a minus 1, a plus 4. Difference is 5. Difference it is 5. That means if this is divisible by 5, this will also be divisible by 5. This will also be divisible by 5. Is the idea clear to you? Is the idea clear to you? A minus 1 into a plus 4. In case if you want a better idea, I will also do like this. A minus 1 into a plus 4. A minus 1 into a plus 4. If a minus 1 is divisible by 5, if a minus 1 is divisible by 5, I also want to prove you that a plus 4 also will be divisible by 5. This is my statement. If a minus 1 is divisible by 5, a plus 4 also is divisible by 5. That is what I am telling. Why? Because the difference it is 5. How you can prove it? Very easily. So if a minus 1, a plus 4 can be written as a minus 1 plus 5. Are you all with me? So this will become a minus 1 whole square plus 5 into a minus 1. Anyway, it is divisible by 5. This is divisible by 5. Are you all with me? This is divisible by 5. Here when you are writing a plus 4 as a minus 1 plus 5, a minus 1 is already divisible by 5. 5 is also divisible by 5. So therefore, a plus 4 also is divisible by 5. I hope it is clear. That is the reason. Here it is a minus 1, it is 5k. 5k whole square is divisible by 25. 5 into 5k, 25k. This entire term is divisible by 25. I hope the idea it is clear. A minus 2 into a plus 7. A minus 2 into a plus 7. What is the number it will be divisible? What is the difference? Difference it is 9. That means if a minus 2 it is divisible by 9, these also will be divisible by 9. That means the expression will be divisible by 81. Expression will be divisible by 81. I hope the logic it is clear. I hope you understood the beautiful way of solving this question just by observation. It is a minus 10, a plus 7. A minus 10 into a plus 7. Difference is 17. That means if this number is divisible by 17, these also will be divisible by 17. Already we wrote a plus 7 can be written as a minus 10, a minus 10 plus 17. A minus 10 divisible by 17 plus 17, it is divisible by 17. Very, very good question. My idea is to give you some thought-provoking questions which will help you think logically. Eleventh question. What are all the pairs of positive integers? What are all the pairs of positive integers? When I say positive integers, it is called natural number set. How many pairs of natural number sets are there? Such that x square minus y square equivalent to 63. X square minus y square equivalent to 63. Method 1. One is the traditional method. Another is to get the answer very fast. X and y are natural numbers. This is the first step. X and y are positive integers. Positive integers means x and y are positive integers means natural numbers. If I add two natural numbers, that will always be greater than their difference. Sum of two natural numbers will always be greater than their difference. Sum of two natural numbers will always be greater than difference. Very, very important. This will help us to reduce the number of steps. X square minus y square is x plus y into x minus y equivalent to 63. X plus y into x minus y. Now listen carefully. 63. In how many ways you can write? 63 into 1. 1 into 63. 1 into 63, I will not write it. Why? Because sum of two natural numbers is always greater than their difference. Reverse case, I will not write. 9 into 7. 7 into 9, I will not write. I will not write. 21 into 3. Factors of 63 are 1, 3, 7 and 9, 21, 63. Reverse, 3 into 21, I will not write. I will not write. Why? Because sum of two natural numbers is always greater than their difference. 21 into 3. 21 into 3. I hope it is clear. Totally 63, it is 9 into 7. 9 it is 3 square into 7 power 1. So total factors will be 3 power 0, 3 power 1, 3 power 2, 7 power 0, 7 power 1, 3 2s are 6 factors, 1, 2, 3, 4, 5, 6. How many, what are all the pairs? This is one pair, this is second pair, this is a third pair. This third pair. So answer for this question is, how many pairs of positive integers x comma y will take? How many pairs of positive integers x comma y will take? How many cases we got? 3 cases we got. These 3 cases are eliminated. Why? Because sum of two natural numbers is always greater than their difference. Sum of two natural numbers is always greater than their difference. This is method 1. Method 2. 63, it is 3 square into 7 power 1. So total number of factors. Total number of factors. 3 2s are, it is 6 cases. 6 cases. 3 cases will have x plus y greater than x minus y. 3 cases will have x plus y less than x minus y. Sum of two natural numbers can never be less than their difference. Sum of two natural numbers can never be less than their difference. So answer for this question is 3. You don't need to enumerate all the cases. He is asking how for every value of x there will be a corresponding y value. So how many we got? 3 pairs we got. 3 pairs we got. Next slide is very, very important. Listen carefully. X square minus y square equivalent to 105. X and y are natural numbers. X and y are natural numbers. Another question. X square minus y square equivalent to 105. X and y are integers. X and y are integers. X and y are integers. What is the difference between these two? Let us see. X square minus y square equivalent to 105. X and y are natural numbers. Natural numbers means positive. Integers means positive, 0 and negative. Positive, 0 and negative. So this will become x plus y into x minus y. 105, it is a composite number. If it is a composite number, write down as a power of prime basis. 15 into 7 is 105. 15 into 7 is 105. So totally how many factors are there? 0 to 1, 2 cases, 0 to 1, 2 cases, 0 to 1, 2 cases. Totally 8 ways are there. In that 8 ways, 4 ways will have x plus y greater than x minus y. 4 ways will have x plus y less than x minus y. Sum of two natural numbers less than their difference. Can the sum of two be less than their difference? No. Answer for this question is 4. Answer for this question is 4. Idea clear? In a natural number set, sum of two natural numbers is always greater than their difference. Sum of two natural numbers, anyway, two natural numbers are countable numbers. If you add two positive numbers, how can it be less than their difference? 4 and 2, sum is 6. It is always greater than 4 minus 2. If it is integers, integers means they both can be negative, they both can, one can be negative, another can be positive. So sum of two natural number positive. Suppose if I take 3 and minus 2, 3 minus 2, 1. 1 is 3 minus of minus 2. 1 is less than 5. So in integer that condition is not satisfied. So it is 3 into 5 into 7. 2 into 2 into 2, 8. 8 cases, because it is integers, it is not mandatory that x plus y should be greater than x minus y. So that 4 cases we will not eliminate it if x and y are integers. X and y are integers means it can be positive, it can be negative, it can be 0. It can be 0. Y cannot be 0. Why? Because 105. 105 it is a digital sum, it is 6. 105 digital sum, it is 6. The digital sum of a perfect square is always 1, 4, 7 or 9. The digital sum of a perfect square is always 1, 4, 7 or 9. Another very interesting question. Find 3x square y square if x and y are integers such that. So let me write entire variables to one side. Y square plus 3x square y square minus 30x square is equivalent to 570. Is equivalent to 570. So what I will do, if I take y square common, y square plus 3x square y square, okay. So this is giving me, just by looking at a question, it is giving me a hint that y square plus 3x square common, it is y square minus 10 equivalent to 570. 517. So y square minus 10. I will add minus 10 on left hand side and right hand side. 3x square into y square minus 10 equivalent to 517. Okay. I got it as a product of two terms. What are the two terms? 1 plus 3x square into y square minus 10 is equivalent to 517. Is equivalent to 517. So that means 3x square plus 1 into y square minus 10 is equivalent to 517. Before checking whether 517 is prime or composite, immediately it should strike you. Sum of the odd places 12, sum of the even places 1. 12 minus 1, it is 11. That means right hand side is divisible by 11. So it is a composite number. So this can be written as 1 into 517 or 517 into 1. Simplest way of writing. Because it is divisible by 11. 11 into 11 fours are 44, 47. It can be 11 into, okay. So see here, the mistake which we did. Here we did subtracting by 10. Right hand side we did not do subtracting by 10. Don't do these calculation mistake. So this will become 517 minus 10. It is 507. Here also it is 507. Don't do these calculation mistake. Entire answer will go for a toss. Left hand side we subtracted 10. Right hand side also we should subtract. So these number became 507. 507. 507. What is the sum of the digits? 5 plus 7, 12. That means it is divisible by 3. We will write down one by one. It is 1 into 507. It is 507 into 1. 3 into 169. 3 16s are 48, 27. This is 169 into 3. This is 9 into 3 into 13 square. 13 means 39 into 13. Am I right? The 169 into 3. So 169 can be written as 13 into 13. So 13 into, sorry, it is 13 into 13. So 13 into 39. Yes. And here it can be written as 13 into 39. Reverse case. Reverse case. It is 3 into 169. I hope you are all there with me. So this is 3 into 169. 3 into 13 square. So 3 into 2, total 6 cases I will get. What are that 6 cases we will do? What are that 6 cases? 1 into 507. 507 into 1. 3 into 169, 169 into 3. 39 into 13 and 13 into 39. Any other cases are there? Let us see. So 13 square it is 169. 13 power 1 is 13. So 13 into 3, 39 we took. Now one by one we will discuss. What is the domain of x and y? Domain of x and y, it is integers. Domain of x and y, it is integers. So this will become y square minus 10, it is 1. Y square is 11. Y square 11. Perfect square digital sum has to be 1, 4, 7 or 9. This is out. Y square minus 10 is 507. Y square will become 517. 517. Any perfect square can never end with 2, 3, 7 or 8. It is not possible. Next one. Y square minus 10 is 169. Y square will become 179. Any perfect square ending with 9. Tens place should be even. Not possible. Y square minus 10 is 3. So y square is 13. Not possible. Next case. 3y square minus 10 is 13, y square 23, not possible. So 3x square plus 1, it is 13. 3x square, it is 12. X square, it is 4. X will be plus or minus 2. Y square will be 49. Y will be plus or minus 7. So answer is 3x square y square. 3 into x square, it will be 4. Y square, it will be 49. 3 4s are 12, 12 9s are 108. Answer unit digit should be 108. Answer unit digit should be 108. I wantedly removed the answer option. Why? Because stupid answer options are kept. X and Y are integers. Integer, integer. Answer should be a multiple of 3. Answer should be a multiple of 3. There is only one option which is a multiple of 3. There is only one option which is a multiple of 3. Idea, it is clear. Very, very good question. Idea is to convert these equation as a product of two terms, and because there are squares involved in the term, use the properties of squares and keep on eliminating. 507 plus 10, 7 plus 0, 7. Perfect square never ends with 2, 3, 7 or 8. Y square minus 10 plus 10. 13, 23, not possible. Y square minus 10, 3, 13, not possible. Y square minus 10, 169, 179. Any perfect square ending with 9. Tens place should be an even number. That is the reason we eliminate the cases. We eliminated cases. Here I subtracted 10. Here also I will subtract 10. 517 minus 10 is 507. Some very, very interesting questions that we discussed today. Question where the degree of the term is 5, x and y natural numbers, x and y integers. The first doubt is, sir, the question is like this: x power x equivalent to 2 power of root 200. None of these questions you will find it in any of the regular textbook. X power x equivalent to 2 power root 200. Find the value of x. Find the value of x. X power x equivalent to 2 power root of 200. Find the value of x. Very interesting question it is going to be. Look at the way I am going to solve the question. First two questions are the doubts asked by students. So first I will explain the doubts, then I will get into the problem. X power x equivalent to 2 power root of 200. Every question whatever I am solving, this how I solved this question. This how I solved this question. X power x equivalent to 2 power of root 200. People will apply logarithm, anti-logarithm, all that high level mathematics. I generally do not prefer. I go with the basic foundation of a question. I read the question twice. I will get a hint if I read the question twice. I take the hint and I will try to solve the question. And I try to solve the question. Now see here. Question is x power x equivalent to 2 power root of 200. Again read the question. X power x equivalent to 2 power root of 200. Okay. Left hand side there is a variable. Right hand side it is of the form 2 power root of 200. Right hand side is of the form 2 power something. So left hand side also it should be of the form 2 power something. Let x equivalent to 2 power y. Sir, why you did let x equivalent to 2 power y? Right hand side is of the form 2 power y. So this will become 2 power y power x equivalent to 2 power root of 200. Without having 2 power in the left hand side, you will not get a 2 power in the right hand side. So this will become 2 power a power m power n is a power m into n. Root of 200 is root of 100 into 2. So this will become 2 power xy equivalent to 2 power 10 root 2. 2 power 10 root 2. Are you all with me? 2 power 10 root 2. So xy is equivalent to 10 root 2. What is x value? 2 power y. 2 power y into y equivalent to 2 into 5 into root 2 is 2 power 1 by 2. So this I will write it here. This I will write it here. So 2 power y into y is equivalent to 2 power 3 by 2 into 5. 2 power 3 by 2 into 5. 2 power y into y is equivalent to 2 power 3 by 2 into 5. Now listen carefully. Hare, if it is of the form 2 power y, these both should match. These both should match. These both are not matching. If I can make it matching, I will get the answer. So what I will do is a simple multiplication and division. I will multiply by 2 and I will divide by 2. I will multiply by 2 and I will divide by 2. 2 power y into y. 2 power 3 by 2 into 5. These both should be same. 3 by 2 and 5 both are not same. They should be same. So multiplied by 2 divided by 2. So this will become 2 power y into y is 2 power 1, 2 power 3 by 2. This became 2 power 5 by 2 into 5 by 2. Yes, right now they are matching. Y is 5 by 2. Question is x. What is y? Y is given by log x base 2. Log x base 2 equivalent to 5 by 2. X value is 2 power 5 by 2. Very, very good question. X value is 2 power 5 by 2. X value is 2 power 5 by 2. Very, very good question it is going to be. See here, no logarithm. Y is, these also you don't need to do. These also unnecessarily not get into high level related things. X equivalent to 2 power 5 by 2. So x equivalent to 2 power y. So 2 power 5 by 2. I hope the idea it is clear. Entire idea it is 2 power y into y is 2 power 3 by 2 into 5. These both should match. 3 by 2 and 5 are not matching. I multiplied and divided by 2. Multiplied and divided by 2. That small idea, if you get it, then the process is very easy. This is one step if you know it. If I multiply and divide by 2, I will get the answer. Very, very good question it is. X power x equivalent to 2 power root of 200. Find the value of x. So what I did it, right hand side it is of the form 2 power y. So left hand side also 2 power y. 2 power y power x is 2 power root 200. xy equivalent to root of 200. 200 it is 100 into 2. Root 100 it is 10. xy equivalent to 10 root 2. x it is 2 power y. 2 power y into 5. Y equivalent to 2 into 5 into 2 power half. So it is 2 power 3 by 2 into 5. Very, very good question it is. This is one question. When I was discussing some doubts during 1 o'clock with my this year CAT students. So another interesting way I told them. So a square equivalent to b square plus 76. A square equivalent to b square plus 76. A and b are natural numbers. A and b are natural numbers. How many values AB will take such that this equation is satisfied? A square equivalent to b square plus 76. A and b are natural numbers, belongs to natural numbers. How many values A and b will take such that this equation is satisfied? Because most of the students have already listened to my integral solutions class. They solved like this. Idea is to give you a very interesting way of looking at this problem. Method 1. A square minus B square. A square minus B square equivalent to 76. A and B are natural numbers. How many values A, B will take? How many values A, B will take? Listen carefully, sir. A square minus B square is A plus B into A minus B is equivalent to 76. Again, I will tell you, whenever you are solving any aptitude problem, first read the question. What is given in the question? A and B are natural numbers. A and B are natural numbers. If A and B are natural numbers, what are the cases possible? A odd number, B odd number, or A even number, B even number. A even number, B odd number. A odd number, B even number. These are the 4 cases. Natural numbers are divided into 2 types, odd number as well as even number. 2 odd numbers, 2 even numbers, 1 odd, 1 even. This case and this case, it is not possible, because if A is an even number on square, even number, B is an odd number on square, odd number, even minus odd. What is even minus odd? Even minus odd, it is an odd number. Right hand side is an even number. Right hand side is an even number. Even square minus odd square, it is an odd number. 76 is an even number, not possible. Odd square minus even square, it is an odd number. 76 is an even number, not possible. These 2 cases are not possible. These 2 cases are possible. How it is possible? A is odd, B is odd. Odd number on square, it is an odd number. Odd number on square, odd number. Odd minus odd, even. Even number on square, even. Even number on square, even. Even minus even, it is even. Right hand side, it is even. A odd, B odd, A even, B even. 2 cases, it is possible. 2 cases, it is possible. Now, if I take this case, odd plus odd, even number. Even number is of the form 2k1. Odd minus odd is an even number, again 2k2. This is 2 square into 90. Even if I take the second case, A is even, B is even. Even plus even, even. Even minus even, even. Even into even, even. So this is perfect. Odd plus odd is an even number. Odd minus odd is an even number. Even plus even is an even number. Even minus even, it is an even number. 2 square, it is 4. Cancel. K1 into K2. It is 19. K1 into K2, it is 19. Can I say that A plus B is greater than A minus B? Definitely. Why? Because A and B are natural numbers. Natural numbers are positive numbers. Sum of 2 positive numbers is always greater than their difference. Definitely. So 19 is a prime number. 19 into 1. 1 into 19. 1 into 19 is not the right case. Why? Because K1 is greater than K2. Most of my students solve like this. Absolutely no error in this method. Perfect method. So K1 greater than K2. That means K1 is equivalent to 19. K2 is equivalent to 1. K1, K2. So from these K1 and K2, you will get both the values. So K1 and K2. K1, it is A plus B, A minus B. From there you will get 10, 20, 10 and another is 8. So 20. Some values you will get, you will solve the question. These, we are not interested in the value, how many values A, B will take. He is not asking what is the value of A and B. So K1 is 19, K2 is 1. K1 is 19. If you see here, 2 into 19, 38, 2 into 1, 2. 38 2s are 76. You don't need to do. Write what you don't need. So answer is 1 value. This is one method. This is one method. Method number 1. Method number 1, I hope the idea it is clear. Method number 2. Method number 2. I was telling on a call that this question can also be looked at like this. Method 2. A square is equivalent to B square plus 76. A and B are natural numbers. A and B are natural numbers. How many values AB will take? How many values AB will take? How many values AB will take? This is the question. So what I did is, this is a square function. So I tried using the notation x plus y whole square is equivalent to x square plus 2xy plus y square. Plus y square. Can I use like this? I saw square on the left hand side, I saw square on the right hand side. To a square, if I am adding something, it will become x plus y whole square. That means 2xy plus y square. How much it is? 76. 2xy plus y square. It is 76. 2xy plus y square, it is 76. 76 is a little smaller value. So definitely you will get the answer. X value 1. 2 plus y square is equivalent to 76. Y square 74. Not possible. X value 2. If x value it is 2. So 2 into 2 into y plus y square is equivalent to 76. Is equivalent to 76. See here, listen carefully. If y value 2 into 2, 4, y plus y square, y smaller value 1, 4 plus 1, 5, no, y value 2, 4 plus 8, not possible. If I take y value, for example, 7, y value 7, y value 7, 7 square 49, 49 plus 2, 2s are 4, 4 7s are 28, 28 plus 49, it is 75, 28 plus 49, it is 75. I hope the idea it is clear, right? So, if you observe carefully, x is 3, just a different way of looking at the question. 2 into 3 into y plus y square, it is 76. It is 76. I hope the idea it is clear, right? So a square equivalent to b square plus 76. Tell me which value it will be possible. Suppose if I take 6 square, if y is 6, 6 square 36, 6 3s are 18, 18 2s are 36, 36 plus 36, 36 plus 36, it is 72. It is not possible. Now, if you observe closely here, suppose if I take x value 8, 2 into 3 into y, 2 into x value 8, right? So, x value 8, 2 into 8 into y plus 8 square. It is 64. 76 minus 64. It is 12. 16 by 12. It will be there in fraction. It will be there in fraction. I hope the idea it is clear. I'll just a perspective of solving algebraic equation. 2xy plus y square is equivalent to 76. X and y are natural numbers. X and y are natural numbers. If I take y value 8, I am solving it again. 2 into x into 8 plus 8 square equivalent to 76. 16x equivalent to 76 minus 64. It is 12. X is fraction. Fraction not possible. Y value 8 not possible. Y value 9 onwards it is not possible. 9 square 81. X and y are natural numbers. 81 plus positive it is greater than 81. Y value 7. If these kind of equations are given, how to solve? 2 into 7 into y plus 49 equivalent to 76. 14y equivalent to 27. Y is 27 by 14. Again it is a fraction. This case not possible. If this kind of equations are given, how to find out the value of x? Y is 6. 2 into x into 6 plus 36 equivalent to 76. 12x equivalent to 40. So x will become 3x. X is 10 by 3. Not possible. Not possible. If y is 5, so this will become 10y plus 25, divisible by 5, divisible by 5, 75 not divisible, y5 not possible, y4, it will become 8y plus 16 equivalent to 76, 8y equivalent to 60, y will become 15 by 2, not possible. 4, 5, 6, 7, 8, it is not possible. If y is 3, 6y plus 9 is equivalent to 76, divisible by 3, divisible by 3, 78 not divisible. If y is 2, this will become 4y equivalent to 72. If y equivalent to, sorry, if y here, if it will become these x, I think, these x. If y equivalent to 2, 4x equivalent to 72, x is 18. X is 18, y is 2. See here, x is 18, y is 2. 18 plus 2, 20 square. 20 square equivalent to 18 square plus 76. 324 plus 76, it is 400. Longer method, definitely yes, but you can also look at this question from an a plus b whole square angle. A square equivalent to b square plus 76. B square I called it as x square plus 2xy plus y square. 2xy plus y square, it is 76. We know that x and y are natural numbers. Y cannot go beyond 8. If y is 9, 9 square is 81. 81 plus positive, how can it be 76? Y cannot be 9. Y cannot be 9. One by one we can eliminate. Y cannot be 3. You don't need to do all these. All these you don't need. See here, I will simplify this question. I will simplify this question by telling you. See here, simplify this question. 2xy plus y square equivalent to 76. First thing, step number 1, y has to be less than 9. Why? Because y is a natural number. 9 square plus something, 81 plus positive, how can it be 76? So y is less than 9. Y cannot be equivalent to 365. Y cannot be equivalent to 365. This is divisible by 3, D is divisible by 3. 76 is not divisible by 3. So 3 multiples 3 and 6 out. This is divisible by 5, this is divisible by 5. 76 is not divisible by 5. 3, 6 and 5 out. Next one, if I take 8, this is divisible by 8, this is divisible by 8. 76 is not divisible by 8. 76 is not divisible by 8. So 3, 6, 5. If I take 7, 7 means this is divisible by 7, this is divisible by 7. 76 is not divisible by 7. Why not equivalent to 7? 7, 8, 6, 5, 3. If it is 4, 4 we have to check. If it is 4, 4 into 2, 8. 4 square, 16 divisible by 8. It is also not possible. 7, 8, 6, 5, 4, 3. 1 anyway not possible. So check it out with y equivalent to 2. You don't need to do all this. I hope the idea it is clear. All this is not required. All this is not required. All this is not required. I hope the idea it is clear. Simple concept of divisibility rule of numbers, we can use it. 2xy plus y square equivalent to 76. Let me do one more question. Let me do one more question so that you will get an idea. 2xy plus y square, 2xy plus y square equivalent to 55. X and y are natural numbers. X and y are natural numbers. How many values xy will take? How many values xy will take? 2xy plus y square is equivalent to 55. Listen carefully, sir. 2xy plus y square. Can y go beyond 7? 8 square, 64 plus positive. No. So y has to be less than 8. Y has to be less than 8. What is the first step? y cannot be take 3 divisible by 3, divisible by 3. 55 is not divisible by 3. Y cannot take any multiples of 3. 6 out. Y cannot take 7 because divisible by 7, divisible by 7. 55, it is not divisible. Here, if I take, y cannot take 2 and 4. Why? Because 2 and 4 will make this number even. 2 square and 4 square, it is an even number. Even plus even, it is an even number. Even plus even, it is an even number. That means 2 not possible, 4 not possible. 1 is a very small value. 1 plus 2, it is 3. 1, 2, 3, 4, 6, 7, all values. The only value, it is 5. So if it is 5, 10y plus 25 is equivalent to 55. Y equivalent to 3. X equivalent to 3. Y equivalent to 5. X equivalent to 3. Is the idea clear? Here you can take y equivalent to 5, x equivalent to 3, or x equivalent to 5, y equivalent to 3. X equivalent to 5. 10, okay. Y only you take it, sir. Y only you take it. Y equivalent to 5. 10y plus 25 is equivalent to 55. So 10x, x equivalent to 3. Is the idea clear? None of the questions, whatever I am taking in class, you will not find in any of the regular textbook. It comes from a person who has authored many mathematical books. Pure understanding of the concept only can make you solve new variety of questions, because most of the teachers solves a lot of PPT problems. Idea is to increase the students' intellect in mathematical and logical ability. I hope the idea it is clear. Let us solve some more questions. Some kind of algebraic questions also you can solve it. Suppose for example, let me give you one more question. X plus y is equivalent to 20. X plus y is equivalent to 20. X square plus y square is equivalent to 208. X square plus y square is equivalent to 208. X and y are natural numbers. X and y are natural numbers. How many values x will take? How many values x will take which will satisfy this equation? Question is x plus y is equivalent to 20. Okay. X square plus y square is equivalent to 208. X square plus y square is equivalent to 208. How many values xy will take which satisfies this equation? This is the question. If I ask any student how they will solve the question is method 1. Idea is to give you multiple ways of looking at this question. Idea 1. Method 1. What they will do is x plus y is 20. So y will become 20 minus x. We are so habituated with this method. X square plus 20 minus x whole square is equivalent to 208. So x square plus 400 minus 40x plus x square is equivalent to 208. 2x square minus 40x plus 192 is equivalent to 0. X square minus 20x plus 96 equivalent to 0. X equivalent to 12 comma 8. X equivalent to 12 comma 8. This is how many students will solve this problem. Almost out of 100 students, 95 plus students will follow this approach. This entire thing is a waste of time. This entire thing is a waste of time. Method 2. X plus y is 20. If I square this one, x square plus y square plus 2xy is 400. So x square plus y square is 208. 2xy equivalent to 192. xy is equivalent to 96. Sum of the roots is given, product of the roots is given. So the equation will become, are you all with me? Sum of the roots is 20, product of the roots is 96. So the equation will become p square minus of sum of the roots plus product of the roots. This is method number 2. You don't need to write anything, just to square the value. Method 1 and method 2. Method 2 is an algebraic way of solving the question. Method 1 is substituting y equivalent to 20 minus x. Substituting y equivalent to 20 minus x. If Anil Nair students are solving the question, how they will solve the question is x plus y is equivalent to 208. X square plus y square is equivalent to x plus y is 20. X square plus y square is 208. X and y are natural numbers. First point, right hand side unit digit. What is the right hand side unit digit? 8. What are the possible unit digits of left hand side? 8 plus 0, 1 plus 7, 2 plus 6, 3 plus 5, 4 plus 4, are you all with me? 9 plus 9, 18. 8 plus 0, 8, 1 plus 7, 8, 2 plus 6, 8, 3 plus 5, 8, 4 plus 4, 8, 9 plus 9 also it is 18. Now listen carefully. How am I eliminating? Perfect square never ends with 2, 3, 7 or 8. Any perfect square ending with 4, tens place it is even. Any perfect square ending with 9, tens place it is even. So this will become 9 plus 9, 18, 1 carried. Even plus even, even. Even plus 1 odd number. 0 is present. So this case out. This case out. How will I get 0? This can be 144 plus 64. So x is 12, y is 8. Just by looking at the question, if you are perfect in number system, you can solve this question very, very easily. Very, very easily. I hope the idea it is clear. Right hand side unit digit is 8. 8 plus 0, 1 plus 7, 2 plus 6, 3 plus 5, 4 plus 4 and 9 plus 9. 9 plus 9 is 18, unit digit 8. 4 plus 4, 8. 3 plus 5, 8. 2 plus 6, 8. 1 plus 7, 8. 8 plus 0, 8. Any perfect square never ends with. Simple logic, sir. Any perfect square never ends with 2, 3, 7 or 8. Any perfect square never ends with 2, 3, 7 or 8. So, all these cases are out. Perfect square ending with 9. Tens place even, tens place even. 9 plus 9, 18. 1 carried. Even plus even, even. Even plus 1 odd. I will get tens place odd. But according to the question, tens place is 0. These are not possible. These are not possible. I hope the idea it is clear. So here 4 plus 4, 8. Here it is 0. 0 which all cases I will get? 0 plus 0, 4 plus 4 is 8. 2 plus 8, 2 plus 8, 24 and 84. 28 square is 784. Next is 44 and 64. Smallest number on square gives 44, it is 144. 144 and 64. Very interesting way of looking at these question. I hope the idea it is clear. Idea it is clear. Now another question. Another question, one student asked me this question. 2 power m minus 2 power n is 63. M and n are natural numbers. How many values mn will take such that this equation is satisfied? Such that this equation is satisfied. Let me keep this as question 1. Right hand side he asked a question odd number. Let me take even number also. Question number 2. 2 power m minus 2 power n is 2016. 2 power m minus 2 power n is 20n6. Mn are natural numbers. How many values mn will take such that this equation is satisfied? 2 power m minus 2 power n is 63. Mn are natural numbers. How many values Mn will take such that this equation is satisfied? 2 power m minus 2 power n is 2016. 1 is an odd number. What happens if it is an even number? Question number 1. Listen carefully. 2 power m minus 2 power n, it is 63. 2 power m minus 2 power n, it is 63. First thing, read the question again and again. 63 is an odd number. 2 power, it is an even number. Even minus even, it will be an even number. The only case possible is one is an even number, another is an odd number. Another is an odd number. Are you all with me? Power of 2, which it will be odd? 2 power 0 is equivalent to 1. So 2 power m equivalent to 64. M value will be equivalent to 6. M value will be equivalent to 6. Another answer is 0, 6. Question is Mn are natural numbers. If Mn are natural numbers, you can directly say no value. How you can say no value? Mn are natural numbers. If Mn are natural numbers, 2 power any natural number is always an even number. 2 power any natural number, 2 power 1, 2 power 2, 2 power 3, 2 power 4, anything it will be an even number. Even minus even. Even minus even. What is even minus even? It is an even number. First question, it is easy. Question number 2. Question number 2. If Mn and n are natural numbers, power of 2 will always be an even number. Right hand side, it is an even number. Right hand side, it is an even number. 2 power m minus 2 power n is equivalent to 2016. Mn are natural numbers. Mn are natural numbers. How many values m will take? How many values m will take? Again, two ways of solving the problem I will tell you. One is a traditional method to solve the problem. Another is Anil Nair's way of solving. Method 1. Traditional way of solving the question. How I will solve this question is 2 power m minus 2 power n. It is 2016. That means 2 power m is greater than 2 power n. Because it is greater, then only answer is positive. 2 power m is greater than 2 power n. That means m is greater than n. M is greater than n. M is greater than n means m will be n plus some positive value. I hope this step is clear. Traditional mathematical way of looking at this question. This value is greater than this number. So 2 power m is greater than 2 power n. That means m is greater than n. M is greater than n. 3 is greater than 1. So 3 will be equivalent to 1 plus 2. 5 is greater than 2. 5 is equivalent to 2 plus 3. So m is equivalent to n plus k, k greater than 0. Traditional method. 2 power n plus k minus 2 power n is equivalent to 2016. So 2 power n into 2 power k minus 1 is equivalent to 2016. 2016. This is an even number. 2 power k, even minus 1, it is an odd number. If I can write like even and odd, I will get the answer. 2016, it is 2 into 1008. It will be 2 into 504. This will be 2 into 2 into 2 into 272. This will be 2 cube into 2 into 136. This will be 2 cube into 2 into 2 square into 17. That means this will be 2 power 6 into 17. 2 power 6. Somewhere we did a mistake because 4 7s are 28. Let me check the calculation. So 2 into, first step it is right, 2016. Second step also it is 1008, it is right. For third step it is 2 into 2, 2 into 252. So we will come to know by using unit digit if we do any calculation mistake. 2 power 6 it is 64. 64, 4 7s are 28. Unit digit has to be 6. So this will be 2 into 2 into 2 into 252. So this will be 2 cube into 2 into 126. This will be 2 into 63. 2 power 5 into 63 is 2 power 6 minus 1. 63 is 2 power 6 minus 1. So this is 2 power 5 into 2 power 6 minus 1. So n is 5, k is 6. M will become n plus k. This is the traditional method of solving the problem. We are not interested in using little advanced level problems. What is very important in this is, please observe, 2 power m minus 2 power n is 2016. Even minus even, it will be an even number. Okay. So definitely first value will be greater than second value. So 2 power m is greater than 2 power n. Powers m is greater than n. M equivalent to n plus k. K is greater than 0. Why? Because m is greater than n. So 2 power n into 2 power k minus 1 is 2016. 2 power any number even number, 2 power k minus 1 odd number. Even into odd. I am writing this number as an even into odd. If you ask me, I would not suggest you to use this method. Time consuming method, mathematical method. What we will do is, we will just try to think very logically this question and try to solve it. If you are a person who loves to solve mathematics using logical thinking, just to think logically, you will get the answer faster than the mathematical process. 2 power m minus 2 power n is 2016. Mn are natural numbers. Mn are natural numbers. How many values Mn will take? How many values Mn will take? If whenever I am solving this question, the logical way to solve this question, how I will solve this question? Logically. Logical way. Listen carefully. 2 power n is subtracted from 2 power m. To get the answer 2016. 2 power n is subtracted from 2 power m. Can I say 2 power m should be greater than 2016? Are you all with me? If it is 2016, anyway, power of 2 will never give you. 2 power 10 is 1024. 2 power 11 is 2048. Even if it is 2016, if I am subtracting some number from 2016, how will I get to 2016 when 2 power n itself is positive? That means, looking at the question itself, I can say that 2 power m is greater than 2016. What is the power of 2 just greater than 2016? 2 power 11 is 2048. So 2048 minus 2016. It is 2 power n. 32 equivalent to 2 power n. So n value is equivalent to 5. This is exactly what I wanted to build through these special sessions. One way is to attack by using a mathematical way, probably by using algebraic identities way, by using some formula method. Can we come out of that logical? Can we do the problem in a very logical, structured thinking way rather than doing it in a mathematical way? See, any learner, in case if he wants to learn mathematics, the first thing is he should be able to visualize that scenario. If you are not able to visualize the problem statement, then probably you will never be able to understand the question in a logical way. Your mind will not push you towards thinking it logically if you cannot visualize the question. This question is a pure visualization question. 2 power m from 2 power m, I am subtracting 2 power n to get answer 2016. Definitely this value should be greater than 2016. What is the power of 2? That is just greater than 2016. 2 power 11 is 2048. So 2048. Now a smart student might ask me, sir, you just found out the power of 2. power of 2, and you did the lowest power. Why it cannot be answer m value, any other value? Suppose, see here, this is 2 power m, this is 2 power n. If I take m value 12, 2 power 12, 2 power 12, it will be 4096. Think logically, from 4000, I need to subtract from 4096 minus 2 power n will give you 2010. It is 2080. Any perfect square ends with even number of zeros. Any perfect square ends with even number of. You can keep on proving by taking one or two values. See, 2 power m, 2 power n, right? If this value is closer to this value, power of n value will be very, very small. If you are increasing value of n, you have to check whether it is working or not. Coincidentally, it will not work because the difference is just close to 2016. Here the difference is coming to, again, 2 power n is 2080. It is not possible. Suppose if I take m value 13, here it is 2 power 13. It is 8192. It is 8192 minus 2016 minus 2016. Are you all with me? Now if you see here, now if you see, it is 2 power n, 2 power n. So 2, 12 minus 6, 6, 8 minus 1, 7. It is 80, it is 6076. 6076 as a power of 2. Not possible. You can check some values. I hope the idea it is clear. Idea is to visualize this question. I'll give you one more question so that let me do one question so that you will understand the power of visualization. Let me take some numbers. 120 into 122 into 124 into 126 plus n. This number is a perfect square. This number is a perfect square. What is the minimum value of n such that the left hand side becomes a perfect square? Very, very good question. Exam relevant question. Question is 120 into 122 into 124 into 126. I will tell you 3 different methods. I am more interested in making my students learn method number 3. Method 1 and 2 you will find it in regular textbook. If I am teaching the concept which is there in the regular textbook, then there is no value addition which I am creating for you. 120, 122, 124, 126. Method 1. Method 1. How students will solve this question is, let 120 is equivalent to a. So this will become a plus 2, a plus 4, a plus 6. Are you all with me? Plus n. This almost everybody knows this approach. A into a plus 6. A square plus 6a. A square plus 6a plus 8. If I take this value p, if I take this p into p plus 8. So this will become p square plus 8, a square plus 2ab. So this has to be 16. N value it has to be 16. N value it has to be 16. Are you all with me? Very algebraic way of solving. 120 it is a, 122 a plus 2, 124 a plus 4, 126 a plus 6. First into last, second into third. If I take this as p, p into p plus 8, p square plus 8p plus 16. So this will form a square. A square plus 2 into 4 into p plus 4 square. N is 16. Method 2. Method 2 is the derivative of method 1. 120, 122, 124, 126. How many terms are there? 4 terms are there. Number of terms are 4. What is the difference between the terms? Difference between the terms. What is the difference between the terms? It is 2. difference between the terms, it is 2. These I am least interested in telling like this. There is a formula. So it is 2 power 4 plus 16 will give you perfect square. The difference between the terms, it is 4. Difference it is 2, number of terms are 4. So if I add 2 power 4, I will get the answer. Sir, how that formula is derived? I am more interested in that approach. I am more interested in this approach. 120, 122, 124, 126. Are you all with me? Plus n, it is a perfect square. Now, listen carefully, sir. How I am solving this question? Listen carefully. 120, 122, 124, 126 plus n, it is a perfect square. Plus n, it is a perfect square. Find the value of n. Find the value of n. Assume options are like this: 16, 9, 25. 4, 16, 9, 25. If Anil Nair students are solving this question, how they will solve the question? 120, 122, 124, 126. These numbers are in arithmetic progression. So, first term plus last term by 2. Average can also be defined as first term plus last term by 2. It is also equivalent to second term plus second last term by 2. So this I can write it as, I have 123 minus 3, first one. Last one it will be 123 plus 3. Are you all with me? Second term can be written as 123 minus 1. And here it can be written as 123 plus 1. Over answer. Just by looking at the question itself, you will get the answer. This will become 123 square minus 3 square. This will become 123 square minus 1 square. What is the difference between these two? 8. Difference between these two, 8. By looking at the question, if I keep 4, this will be x square. If 4 comes this side, x minus 2, x plus 2. What is the difference? 4. But how much I require? 8. If I keep 16, this is x square. X minus 4, x plus 4. What is the difference? 8. Simple. By looking at the question itself, I will get the answer as 16. By looking at the question itself, I will get the answer of 16. Very powerful ways of solving a problem. You can also use average concept and you can do the question. I saw the question 120, 122, 124, 126. The series is in arithmetic progression. So average is first term plus last term by 2. It is also equivalent to second term plus second last term by 2. 120, 126. Average is 123. 3 units forward from lowest value is equivalent to 3 units backward from highest value. 123 minus 3, 123 plus 3. 123 minus 1, 123 plus 1. 123 square minus 3 square, 123 square plus 3 square. You can, even if answer options are not there, these difference it is 8. So, it will become p square x square minus n. So x minus root n, x plus root n. Are you all with me? N can be written as root n whole square. X minus root n, x plus root n. Deviation is 2 root n. 2 root n is 8. So n value it is 16. Idea clear? Are you all clear with the idea? One needs to look at this question from a non-mathematical angle. I am more interested. I am taking these classes to show you aptitude through a different prism altogether. Idea is to tell that, especially for a non-max students, do not get intimidated looking at a question. Visualize the question. Understand the root cause of the problem. Simplify the problem. Do not complicate the problem. I hope the idea it is clear. Now see here how beautifully you can solve this question. 91 into 90. First we will take even number, then I will get into an odd number. 2 into 5 into 8 into 11 plus n, it is a perfect square. Plus n, it is a perfect square. Immediately it should strike you. Oh, 2, 5, 8, 11. This is in arithmetic progression. So this will become 6.5. 11 plus 2 by 2, 13 by 2. 6.5 minus 4.5. Are you all with me? 6.5 plus 4.5. 6.5 minus 1.5. 6.5 plus 1.5. I hope it is clear. From where this 6.5 came? 2 plus 11 by 2, 5 plus 8 by 2. So this will become 6.5 whole square minus 4.5 whole square. This will become 6.5 whole square minus 1.5 whole square. Are you all with me? So what is the difference? Difference is 4.5 whole square minus 1.5 whole square. This is 3 into 6. A minus b into a plus b. It is x square. So it is 2 root n. So 18 equivalent to 2 root n. Root n is 9. N is 81. N is 81. So even from the answer option, x square minus 9 square, x minus 9 into x plus 9. Difference it is 18. Idea is to tell you this can be in a decimal value or this cannot be in a decimal value. Very, very interesting ways to look at this problem. Every session what I discussed, session 1, session 2, session 3. Now it is session number 4. I will again come back at session number 5 and I will try to solve some another very interesting questions. One good doubt asked by a student. Let me start with that good doubt. I hope the logic it is clear. So I did 4 terms. You can also probably try it out with 3 terms, 4 terms, so on and so forth. Right? I hope the idea it is clear how to do by using answer option, how to do by using algebraic method, how to solve this problem logically, how to solve this problem mathematically. Odd minus odd is even, odd plus odd is even, even minus even, it is even. Even minus even, it is even. I hope every question, this question idea it is also clear, right? So left hand side square, right hand square square. Just a different way of looking at this question. Ideally, if you ask me, you should go by this method. This method is much more simplified method. You can also solve by using these kind of questions. I hope it is clear. It is not only x square plus 2y square. Suppose if there is a question like this, a cube equivalent to b cube plus, suppose for example, 124 it is there. You can try looking at this question from this angle. It is x cube. It is y cube plus 3xy into y plus y equivalent to 124. Just a random idea. So y cube plus 3xy into 1 plus y is equivalent to 124. Already we did this method. Y cannot be 5. 5 cube plus positive. Y cannot be, just by looking at a question, y cannot be 5, y cannot be 3. Multiple of 3 plus multiple of 3. It is not possible. If y is, for example, y can be 4, y can be 2 or y can be 1. Y can be 1. 1 will become 1 plus these, these, check it out whether it is becoming y value. X cube plus y cube plus 3xy into 1 plus y. Instead of giving a spoon feeding, this kind of questions can also be generated if the logic is very clear. I hope you enjoyed the session. In case if you, while listening to the class, in case if you think that you are learning something from the class and you appreciate the effort, kindly give a like button and share it with all your friends. Question is 2 power 8 plus 2 power 11 plus 2 power n. It is a perfect square. 2 power 8 plus 2 power 11. plus 2 power n. It is a perfect square. Find the value of n. Find the value of n. This is an age-old mathematical Olympiad question. 2 power 8 plus 2 power 11 plus 2 power n. It is a perfect square. Find the value of n. Similar question in management examination. 2 power 4 plus 2 power 7 plus 2 power n. It is a perfect square. Find the value of n. 2 power 4 plus 2 power 7 plus 2 power n. It is a perfect square. Find the value of n. This question is inspired from this question. 2 power 4 plus 2 power 7 plus 2 power n. If it is a perfect square, find the value of n. Answer options I removed it because if answer options are there, just substitute it and check it out whether the left hand side is a perfect square or not. Multiple ways of solving a problem. Method 1. Method 1. This is a very smaller value. 2 power 4 is 16. 2 power 7 is 128. These are all smaller values. Method 1. 2 power 4 it is 16. 2 power 7 it is 128. Plus 2 power n. It is a perfect square. Perfect square is k square. So 128 plus 16 is 144. 144 plus 2 power n. It is k square. The same approach what we used initially, the same approach to which we will do it. This will become k minus 12 into k plus 12. 144 can be written as 12 square. It is equivalent to 2 power n. It is equivalent to 2 power n. Now listen carefully. Look at the question. 16 plus 128 plus 2 power n is k square. K square minus 144 is 2 power n. K minus 12 into k plus 12. Now if you observe carefully, what is the difference between these two numbers? K plus 12 and k minus 12. Difference it is 24. So let us see powers of 2 where the difference is 24. 2 power 1 it is 2, 2 power 2 it is 4, 2 power 3 it is 8, 2 power 4 it is 16, 2 power 5 it is 32. 2 power 5 it is 32. Now if you observe closely here, it's a pure observational question. 32 minus 8 is 24. 32 minus 8 is 24. So this is a smaller value, 2 cube and 2 power 5. So 2 power 5 is 32, 2 cube it is 8, 32 minus 8 is 24. So k plus 12 will become 32. K plus 12 will become 32. K will become 20. K will become 20. If it is 20, 20 square is 400. 400 minus 144, it is 256. 2 power n is 256. So n value will become 8. This is one way to solve this question. This is one way to solve this question. I hope the idea it is clear. 2 power 4 is 16, 2 power 7 is 128, plus 2 power n is k square. 128 plus 16 is 144. 144 plus 2 power n is k square. K minus 12, k plus 12. The difference between the terms in the left hand side, it is 24. Right hand side powers of 2, check it out, where is the difference? 24. 32 minus 8, it is 24. That means 2 power 5 can be given to k plus 12. 2 power 3 can be given to k minus 12. K plus 12 is 32. K will become 20. 20 square is 400. 400 minus 144 is 256. 2 power n is 256. N value will be 8. N value will be 8. This is one way to look at this question. Another way to look at this question. This is a perfect square. What is a perfect square? A square, a plus b whole square, a plus b power 4. Perfect square power will be an even number including 0. So this will become 2 power 4 is 2 square whole square, a square. Next it is 2ab. 2 power 3 over, remaining it is 2 power 4. 4 plus 2 plus 1 it is 7. Yes. So a square 2ab, remaining it will be b square. 2 power 4 whole square. 2 power 4 whole square is 2 power 8. 2 power 8 is 2 power n. N value it is 8. I hope the idea it is clear. Because it is a perfect square, Because it is a perfect square and there are three terms on the left hand side. One term, second term, third term. There are three terms on the left hand side. So it is of the form a plus b whole square. This is a square. This is 2ab and it is b square. A square, 2 square whole square. 2ab, 2 into 2 square, 2 cube. This will become 2 power 4. So this will become 2 power 4 power 2. 2 power 8. So n value will be 8. I hope the idea it is clear. The same idea, if I carry forward to the first question, this is not going to be a formula driven class. Every question whatever I solve will be very logical, very conceptual. Again 3 terms are there. If 3 terms are there, so this will become, if 3 terms are there, so this will become 2 power 4 power 2. This will become 2 into 2 power 4. Remaining it will be 2 power 6. So here it will become 2 power 12. So n value it is 12. Just by looking at the question itself you will get the idea. What is another idea? 2 power 8. 2 power 8 common, 1 plus 2 power 3 9. 9 into 256 k. 9 into 256 can be written as 3 square into 16 square. So it is 48 square. K minus 48, k plus 48, difference should be 96. Which power of 2? It will give you difference 96. Please check it out. I hope this method is clear. Because in the previous question we discussed, what is the question that we discussed? See here, difference we have seen. Difference, same thing here. Difference also we will see. K plus 12, k minus 12, difference it is 24. So same approach we will try to do. I hope the logic it is very, very clear to you. Let us see one more question based on perfect square. Find all the prime values P can take. Find all the prime values P takes such that 71P plus 71P plus 1, it is a perfect square. I don't know if there will be any prime values, just an idea based question. Find all the prime values P can take such that 71P plus 1, it is a perfect square. Same logic we will use. The root cause of the problem is P is a prime number. P it is a prime number. So 71P plus 1, it is a perfect square. So it is K square. So 71P, it is equivalent to K square minus 1. K square minus 1. So this will become 70, K square minus 1 is K minus 1 into K plus 1. K minus 1 into K plus 1. These difference it is 2. These difference it should be 2. 71 2 difference. Number will become 69 or 73. 73 it is a prime number. So 71 into 73 is equivalent to K minus 1 into K plus 1. Here the difference it is 2. Here also difference it is 2. So K plus 1 it is 73. K will become 72. K will become 72. And P will become 73. How beautifully the question can be created if your logical understanding of the concept is very good. What I did previous question, difference it is 2. The same idea I did it. Find all the prime values P can take such that 71P plus 1 it is a perfect square. Any perfect square is of the form K square. K minus 1, K plus 1. These difference it is 2. 71 into another number, difference should be 2. So it can be 69 or 73. 69 is a composite number. So it is 73. So K plus 1 is 73. So K value will be 72 and P value will be 73. I hope the idea it is clear. Let me create another question. Prime number we have taken, right? So let us create. What is the value of n? What is the value of n? Such that n by 2, it is a perfect square. N by 2, it is a perfect square. N by 3, it is a perfect cube. N by 2, it is a perfect square. N by 3, it is a perfect cube. N by 5, it is fifth power. N by 2, it is a perfect square. N by 3, it is a perfect cube. N by 5, it is a fifth power. When you divide a number by 2, n is a natural number. When you divide a number by 2, I will get a perfect square. When you divide a number by 3, I will get a perfect cube. When you divide a number by 5, I will get a fifth power. What is the value of n that will satisfy? Or what is the minimum value of n? There could be more values. So, what is the minimum value of n that will satisfy? What is the minimum value of n that will satisfy the question? N minimum value. N by 2, it is a perfect square. N by 3, it is a perfect cube. N by 5, it is a fifth power. The number is getting divided by 2, 3 and 5. Any natural number can be written as a power of prime basis because it is getting divided by 2, 3 and 5. Number form will be 2 power a, 3 power b, 5 power c. Number form will be 2 power a, 3 power b, 5 power c. Why we did 2 power a, 3 power b, 5 power c? When you divide a number by 2, there is the right hand side is becoming a perfect square. So when you divide a number by 3, number is getting divided by 2, 3 and 5 according to the question. Any natural number can be written as a power of prime basis. 2 power k1, 3 power k2, 5 power k3 and so on. So here 2, 3, 5 we are restricting because the question contains n by 2, n by 3, n by 5. Read the question again and again, you will get an idea. N by 2, it is a perfect square. So if I divide it by, so 2 power a by 2, a minus 1, 3 power b and 5 power c. What is the conclusion? What do you mean by perfect square? Power should be an multiple of 2. Perfect square means number multiplied by itself. Power should be a multiple of 2. Power should be a multiple of 2. That means a minus 1, b comma c, all are multiples of 2. A minus 1, b comma c. All are multiples of 2. I hope this concept is clear. N will be 2 power a by 2. This will become 2 power a minus 1 into 3 power b into 5 power c. Because it's a perfect square, power should be a multiple of 2. Similarly, n by 3. So this will become n by 3. So this will become 2 power a into 3 power b minus 1 into 5 power c. It is a perfect cube. Perfect cube means power should be a multiple of 3. Power should be a multiple of 3. A, b minus 1 comma c, all are multiples of 3. A, b minus 1 c, all are multiples of 3. A, b minus 1 c, all are multiples of 3. All are multiples of 3. I hope the idea it is clear. We are just one step away from the answer. If we understand the logic, just go step by step. N by 5, it is a fifth power. That means n equivalent to 2 power a into 3 power b into 5 power c minus 1. This is a multiple of 3. A comma b comma c minus 1. They are all multiples of 5. They are all fifth power. So they are all multiples of 5. They are all multiples of 5. These 3 boxes, it is clear to you. Perfect square means power should be a multiple of 2. A minus 1, b, c are multiples of 2. Power should be a multiple of 3. A, b minus 1, c are multiples of 3. A, b, c minus 1. They are all multiples of 5. Now one by one we will go. A, b, c minus 1, they are multiples of 5. If I take a value, 5, 10, 15 and so on. A5 from bottom to top. A5. Is 5 a multiple of 3? No. these are not possible. 10. 10, is it a multiple of 3? No. 15. 15 is a multiple of 5. 15 is a multiple of 3. 15 minus 1. 14, it is a multiple of 2. So, a minimum, it is 15. A minimum, it is 15. B, if it is a multiple of 5. 5 minus 1. 4. 4, is it a multiple of 5? No. 5 not possible. 10. 10 minus 1, 9 is a multiple of 3. 10 is a multiple of 2. So, B minimum, it is 10. B minimum, it is 10. C, if it is 5, 5 is a multiple of 3, not possible. 10 is a multiple of 3, not possible. C minus 1, if it is multiple of 5, 5 plus 1, 6. C minus 1 is 5K. So, K1, C is 6. 6 is a multiple of 3. 6 is a multiple of 2. So, C minimum, it is 6. Check it out whether all the conditions are satisfied. If nothing is satisfying, then this cannot be. A minimum, it is 15. 15 minus 1, 14, multiple of 2. 15 multiple of 3. 15 multiple of 5. First one, okay. B minimum, 10. 10 is a multiple of 2. 10 minus 1, 9 is a multiple of 3. 10 is a multiple of 5. Yes, perfect. C, it is 6. Multiple of 2. C is a multiple of 3. C minus 1, 6 minus 1. 6 minus 1. It is 5. So, answer will be, N will be 2 power 15 into 3 power 10 into 5 power 6. N will be 3 power 10, 2 power 15 into 3 power 10 into 5 power 6. This is a traditional way of solving the question. This is a traditional way of solving the question. N equivalent to 2 power 15 into 3 power 10 into 5 power 6. Now what we will do is, we will do a bottom up parsing. From niche se upar, we will come from bottom and we will go to the top. What is the question? N by 2, it is a perfect square. N by 2, it is a perfect square. Perfect square means this can be 2 square, this can be 2 power 4, 2 power 6 and so on. Perfect square will have a power, a multiple of 2. N by 3, it is a perfect cube. Perfect cube means 3 power 3, 3 power 6, 3 power 9 and so on. Are you all with me? N by 5, it is a fifth power. Fifth power means 5 power 5, 5 power 10, 5 power 15 and so on. And so on. Suppose I need a combination of 2, 3 and 5. We will start from 5. Suppose if I take 5 power 5, 5 power 5, 5 power 5 into 5, 5 power 6. 5 power 6 divided by 5. 5 power 5, it is satisfying. Suppose if I take 3 power 4, 3 power 4 divided by 3. 3 cube, satisfying. 3 power 4 divided by 5, not satisfying. So take that values which will satisfy all the conditions. So I will take N is 5 power 6 from here. 5 power 5 into 5. 3 cube into 3, not satisfied. 3 power 6 into 3. 3 power 7. 3 power 7, not satisfying. 3 power 10. 3 power 10. So 3 power 10. Power should be an multiple of 2. 6 plus 1, 7. Not possible. Are you all with me? 10 plus 1. It is not possible. 5 plus 1, 6. So 5 power 6. Clearly we got 9 plus 1, 3, 10. So this will be 2 power 2 plus 1, no 6, like that. If I take 2 power 15. 2 power 15. 2 power 15. Why? Because if I take, it should also be a fifth power. 2 power 15. 15 should be a multiple of 5. Multiple of 5 not possible. You can easily go by the answer option elimination approach. I hope the idea, it is very, very clear to you. 2 power 15 into 3 power 10 into 5 power 6. Just observe the question. N when divided by 5. it should have a fifth power. Otherwise, it would have been 5 power 5. Something divided by 5, I should get a fifth power. So it has to be 5 power 6. Divided by 3, it is a perfect cube. So it has to be 3 power 4, 3 power 7, 3 power 10. So 3 power 4 not a multiple of 3. 3 power 7 not a multiple. 3 power 10. So n equivalent to 2 power 15 into 3 power 10 into 5 power 6. I hope the logic it is clear. I hope the idea it is very clear. A student has asked me this doubt. He was solving some papers. The question is like this. Sir, x minus 2 into x minus 6 into x plus 3 into x plus 4 is equivalent to 16x square. Find x. Find x. This is the doubt asked by a student. X minus 2, x minus 6, x plus 3, x plus 4 is equivalent to 16x square. Find the value of x square. What is the degree of the left hand side? Degree of the left hand side is 4. Sir, should I use degree for some advanced methods? No need to do it. How I solved this question is, I multiplied these two. X square minus 8x plus 12. I multiplied third and fourth. X square plus 7x plus 12 is equivalent to 16x square. When I did first with the second and third with the fourth, immediately I got an idea how to proceed with that problem. This x square, I will shift it to the left hand side. X square minus 8x plus 12 by x. X square plus 7x plus 12 divided by x is equivalent to 16. Is equivalent to 16. Till here clear? X square by x, x minus 8 plus 12 by x. Are you all with me? This will be x plus 7 plus 12 by x. How simply you can solve this question if you read the question twice. Over answer, x plus 12 by x, x plus 12 by x. I will call let x plus 12 by x as a. So this will become a minus 8 into a plus 7 minus 16 is equivalent to 0. So a square minus a minus 72 is equivalent to 0. A minus 9 into a plus 8 is equivalent to 0. A is minus 8 comma 9. So wherever a is there, substitute this value. Substitute this value and get the value. I hope the idea it is clear. Do not get into any equation with a degree 4. Read the question. Probably how I read the question is 3 4s are 12. 2 6s are 12. Okay. That means product of the constants are same. So I will do this with this and this with this. Then suddenly I realized x square plus 12, x square plus 12. They both are common. So I shifted to x. Then I got x plus 12 by x. X plus 12 by x is a. A minus 8 into a plus 7. It is equivalent to 16. Now very simple quadratic equation I got it. Now from there I will solve the question. So a equivalent to 8 comma minus 8 comma 9. A is x plus 12 by x. X plus 12 by x is minus 8. X plus 12 by x is 9. Solve that equation very easily. You will get the answer. I hope it is clear. If I substitute a equivalent to minus 8, x plus 12 by x is equivalent to minus 8. X plus 12 by x is equivalent to minus 8. Suppose if he gives x is an integer. He has not mentioned if x is an integer. Our jobs becomes very easy. X is a factor of 12. So 1, 2, 3, 4, 6, 12. So if I take x is minus 2. minus 2, minus 6 from these factors. Check it out, which will satisfy the equation. Which will satisfy the equation. I hope the idea it is clear. Very, very good question. Seems like a complex question. Student thought that it's a very advanced question, but actually it's a very easy question. This question also logical way of solving, mathematical way of solving. How many prime values we can take such that it is a perfect square? I hope the idea it is clear. Let me take one more question asked by a student, but for that I will discuss a introductory question. How many distinct factors? How many distinct factors? If you understand this question, next 3 questions will be very easy. How many distinct factors for 72? How many distinct factors for 72 are co-prime to each other? How many distinct factors for 72 are co-prime to each other? This is the question. Very, very good question. I will tell you Anil Nair's way of solving this question. The logic which I am going to discuss, probably in Indian textbooks you will not find it. My way of learning mathematics is, I am not that intelligent enough to remember so many formulas. Sorry, sir. What I will do is, I will read the question again and again. I will try to find out the root cause of a problem. From there, I will solve it. Let me please read the question. Please read the question. Kindly read the question. How many distinct factors? Okay, distinct. This is the first keyword. Factors for 72 are co-prime to each other. 2 numbers are said to be co-prime to each other if their HCF is 1. So HCF of A comma B, it is 1 when A and B are co-prime to each other. 2 numbers are said to be co-primes if their HCF is 1. 2 numbers are said to be co-primes if their HCF is 1. 2 important key. What is he asking? He is asking, take the number 72, write all the factors for 72. Write all the factors for 72. From that factors of 72, take 2 numbers which are co-prime to each other. Write all the factors for 72. Write down all the factors for 72. Take 2 factors which are co-prime to each other. This is the question that he is asking. Small number I took 72. I will build a concept. Then I will take a bigger number. Then I will take a bigger number. Listen carefully, sir. Traditional method. Traditional method. Traditional method. Traditional way of solving this question. Traditional method. 72. Any composite number write down as a power of prime basis. So it is 2 power 3 into 3 power 2. 2 power 3 into 3 power 2. How many factors are there from this number? Number of factors are determined by writing from 0 to 3. Here we are writing from 0 to 2. 4 into 3. Totally 12 factors I will get. Totally 0 to 3, 4, 0 to 2, 3. 4 3s are 12. 12 factors I will get. Listen carefully, sir. Let me list down all the factors of 72. 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, 72. 1, 2, 3, 4, 6. All these numbers perfectly divide 72. All these numbers perfectly divide. 72 perfectly divides 1. 1 perfectly divides 72. 72 is a multiple of 1. 2 perfectly divides 72. 2 is a factor of 72. 3 perfectly divides 72. So all these factors. Totally how many I got? 3, 6, 9, 12. Totally 12 are there. These are the 12 factors. Now, please read the question again. How many distinct factors for 72 are co-prime to each other? From these 12 factors, take 2 numbers which are co-prime to each other. Let me start with 1. 1 with 1 I should not take because the question is distinct. Question is distinct. 1 with 1 I should not take. So I will take 1 with 2. I will take 1 with 3. I will take 1 with 4. and I will continue taking from 1 to the number given. Totally 12 factors are there. 1 is co-prime with every other number. 1 is co-prime with every other number. How many I got? 11 I got. Totally how many I got? 11 I got. Till here, I hope the idea it is clear. So 1 with 2, 1 with 3, 1 with 4, 1 with 6, 1 with 8, 1 with 9, 1 with 72. Out of 12 factors, 1 is co-prime with other remaining 11. So 11. These are the factors which are co-prime with 1. These are the factors which are co-prime with 1. These are the factors which are co-prime with 1. These are the factors which are co-prime with 1. There are also some more doublets which are co-prime to each other. What are the doublets? 2 power 3 into 3 power 2. 2 power 1, 2 power 2, 2 power 3. 3 power 1, 3 power 2. 2 power 1, 3 power 1. 2 and 3 are co-prime to each other. 2 power 1, 3 power 2. 2 with 9 are co-prime. 2 square, 4 and 3 are co-prime. 4 and 9 are co-prime. 8 with 3 are co-prime. 8 with 9 are co-prime. 1, 2, 3, 4, 5, 6. 6 are there. So 11 plus 6. What is the answer for this question? 17. There are 17 distinct factors for 72 which are co-prime to each other. Same question, there will be a formula in most of the textbooks. Without using formulae, how to look at the question and tell the answer, I will discuss the approach. How many distinct factors? What I did? Okay, first let me understand the questions in a simple way. He is telling, take the number 72. I took the number 72. He is asking, write all the factors of 72. Yes, I wrote all the factors for 72. Then he is asking, give me two numbers which are co-prime with each other. Give me two numbers which are co-prime with each other. Two numbers are said to be co-prime if their HCF is 1. So 1 with 1 I should not take because question is distinct. 1 with 2, 1 with 3, 1 with 4, 1 with 72. 11 I took. Then every power of a prime base is co-prime with every other power of a prime base. 2 power 1 is co-prime with 3 power 1. 2 power 2 is co-prime with 3 power 1. 2 power 3 is co-prime with 3 power 1. 2 square, like that 3 into 2, 6 cases. This is a traditional method. By looking at a question, understanding the definition of a co-prime, how can we get the answer very fast? Anil Nair's way. How I should solve this question? Anil Nair's way. Very logically, how I should solve. So, see here, sir. Step number 1. What is the number that is given? 72. 72 can be written as 2 power 3 into 3 square. I want doublets A and B. What is the condition on the doublets? They both should be co-prime to each other. HCF of A comma B, it is 1. HCF of A comma B, it is 1. A can take any power of 2 or any power of 3. B can take any power of 2 or any power of 3. 2 power x2 into 3 power y2. Is it clear? But the condition is HCF of A comma B should be 1. Am I right? HCF of A comma B should be 1. These x1 and x2 can take all the values from 0 to 3. Why from 0 to 3? 72 power of 2, it is 8. Can take values from 0 to 2. 0, y1, y2 less than or equivalent to 2. Is this step clear to you? Is this step clear to you? 0 less than or equivalent to x1, x2 less than or equivalent to 3. 0 less than or equivalent to y1, y2 less than or equivalent to 1. Are you all with me? So, what do you mean by HCF? HCF means lowest power of the given prime basis. Lowest power of the common prime bases. This is the definition of HCF. If there are two prime bases, take the common prime bases, take the lowest. This is the definition of HCF. Nothing I am doing, just I will do the definition. HCF of A comma B should be 1. Lowest power, that means minimum of x1, x2. How much it should be? 0, because 1 can be written as 2 power 0 into 3 power 0. Minimum of x1 and x2 it should be 0. Why minimum of x1 and x2 it should be 0? HCF always takes the lowest power of the common prime bases. Minimum of x1 x2 0. That means if x1 is 0, lowest is 0, x2 can be 0, 1, 2, 3. 0, 0 lowest is 0. 0, 1 lowest is 0. 0, 2 lowest is 0. 0, 3 lowest is 0. Similarly, if x2 it takes lowest, x1 can take 0, 1, 2, 3. 0, 1, 2, 3. 0, 0, 0, 0. It is written twice, so it is eliminated. 4 cases here, 4 cases, 1 case is eliminated. 7 cases I will get. 7 cases I will get. I hope the idea it is clear. Similarly, minimum of y1 and y2. Minimum of y1 comma y2. It is 0. y1 comma y2 it is 0. That means if y1 takes 0, y2 can take 0, 1, 2. If y2 can take 0, y1 can take 0, 1, 2. Are you all with me? 0, 0 duplicated. 5 cases. 5 cases. So from very, very good question, sir. 5 cases. Here 7 cases. Here 5 cases. Total 35 cases I will get, which is an ordered pair. Reverse is also written. Out of this, 17 cases where one is less than another case, 17 cases, one is greater than another case. One case where both are equal. What do you mean by both are equal? 1 comma 1. This case we should not take. There is no variable present in the question. If variables are present in the question, I should use ordered pair. If variables are not present in the question, I should use unordered pair. Variables are not present in the question, so I will use unordered pair. Therefore, the answer for this question is 17. Therefore, answer for this question is 17. I hope the idea it is clear. Again, I am repeating how many distinct factors of 72 are co-prime to each other. Two numbers are said to be co-prime if their HCF is 1. HCF is defined as the lowest power of the common prime bases. That means if this is 0, this can take from 0 to 3. 4 cases. If this is 0, this can take from 0 to 3. 4 cases. 4 plus 4, 8. 1 duplicate, 7 cases. If this is 0, this can take from 0 to 2. 3 cases. If this is 0, this can take from 0 to 2. For 0, 0 to 2. 3 cases and 4 cases. 0, 0, 0, 0, 1, 0, 2. 2, 0, 2, 1, 2, 2. So, if you see here, 3 cases, 3 plus 2, 5 cases. 7 into 5, 35. 35 cases, reverse is also allowed. 17 left side, 17 right side. One case where the both are equal. Question is distinct. Question is distinct. So, variables are not present in the question, so it is an unordered pair. I hope the idea it is clear. Let me do 2 examples. Example. First example. N equivalent to 2 cube into 5 power 4. 2 cube into 5 power 4. If this example is clear, then you can tell the answer orally, sir. N equivalent to, these are something which you will not find in any regular textbook. N is 2 cube into 5 power 4. How many distinct factors? How many distinct factors for n are co-prime to each other? For n are co-prime to each other. I am writing it statement by statement, second also, but third one onwards I will write the answer directly. First we will go logically. Again I am explaining for the second time. They are co-prime to each other. What are the two numbers? A and B. Number is given as 2 cube into 5 power 4. 2 power x1 into 5 power y1. 2 power x2 into 5 power y2. Their HCF should be 1. Two numbers HCF should be 1. Two numbers HCF should be 1. What are x1 and x2? x1 and x2 can range from 0 to 3. y1 and y2 can range from 0 to 4. Can range from 0 to 4. So that I will get all the factors of n. If I keep the same number, 2 cube into 5 power 4. See, x1, if it takes 2 power 1 into 5 power 4, I am extracting the factors from that number which are co-prime to each other. I am extracting the factors which are co-prime. So logic is 1. 1 means 2 power 0 into 5 power 0. So this will be minimum of x1 and x2. It can be 0. Or minimum of y1 and y2. It is 0. Are you all with me? So if x1 is 0, x2 will become 0, 1, 2, 3. If x2 is 0, this will become 0, 1, 2, 3. So 4 cases, 4 plus 4, 8, 0, comma 0 is eliminated. So 7 here. y1 and y2. If y1 it is 0, y2 will be 0, 1, 2, 3, 4. If it is 0, 0, 1, 2, 3, 4. 5 plus 5, 10. 10 means 1 case 0, comma 0, not possible. This case is duplicated. This case is duplicated. 7 into 9, 63. Variables are not present. Reverse not possible. Question is distinct. 31. Are you all with me? 31. I hope the idea it is clear. I hope it is clear. Now, how to write down the answer easily? I hope it is clear. 2 power 3. From this logic only we will write the answer. If this is 0, this can take 0 to 3. 4 cases. If this is 0, this can take 0 to 3. 4 cases. 4 plus 4, 8. 8, 1 case is duplicated. So, what we will do is, if n equivalent to 2 power p into 3 power q into 5 power r. Listen carefully, sir. If this is 0, this will take from 0 to p. 0 to p, how many cases? P plus 1. If this is 0, this will take 0 to p. P plus 1. P plus 1 plus p plus 1. P 2p plus 2. 1 case it is duplicated. So I will get a remaining 2p plus 1. Are you all with me? If it is q, if this is 0, 0 to q, q plus 1. If this is 0, 0 to q, q plus 1. Q plus 1 plus q plus 1, 2q plus 2. 1 case it is duplicated. So it is 2q plus 1. Similarly, the next one is 2r plus 1. This is the proof how you got it. This is the proof how you got it. I hope the logic it is very, very clear. Sir, explain me once again how you got 2p plus 1. If this is 0, minimum power, 2 numbers have got co-prime. Co-prime means 1. 1 means 2 power 0. If it is 0, this can take any value greater than or equivalent to 0. Till p, 0 to p, 0 to p, p plus 1. If this is 0, this will be 0 to p, p plus 1. P plus 1 plus p plus 1, 2p plus 2. 1 case 0, comma 0. Question is distinct. That case needs to be eliminated. P plus 1 plus p plus 1, 2p plus 2. 1 case it is eliminated, 2p plus 1. I hope the idea it is clear. One more example. N equivalent to 2 power 7 into 3 power 4 into 5 cube into 7 square. How many distinct factors? How many distinct factors for n are co-prime to each other? How many distinct factors for n are co-prime to each other. Are co-prime to each other. Tell me the answer. So there will be two numbers, A and B, 2 power x1, 3 power y1, 5 power z1, 7 power. No need to do. x1 takes 0, x2 takes 0 to 7, 8. x2 takes 0, x1 takes 0. 8 plus 8, 16, 1k is duplicated. 2p plus 1, 15. 2 into 4 plus 1. 2 into 3 plus 1. 2 into 2 plus 1. This is ordered pair. This is ordered pair. So one case it will be equal. So this will be 15 into 9 into 7 into 5 plus 1 by 2. Half cases here. 15 into 9 into 7 into 5 plus 1 by 2. Plus 1 by minus 1 by 2 will take. Question is distinct, right? Minus 1 by 2. Here also it is minus 1 by 2. I hope it is clear, both the cases. Minus 1 by 2, minus 1 by 2, minus 1 plus 1 cancel. Very easy question. Now we will go little advanced level. How many factors are there for this number which are co-prime to each other? Now if you observe closely, idea clear? 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, 72. Now I will make it a little difficult. Co-prime means HCF it is 1. Take any two numbers from this one where HCF it is not 1 but 2. 2 comma 4 HCF it is 2. 2 comma 6 HCF it is 2. 2 comma 8 HCF it is 2. 2 comma 12 HCF. So instead of co-prime, let me change the question. Let me change the question. Logic remains the same. I hope you are all enjoying very conceptual problem solving. Suppose, how many, first easy question. How many distinct factors, how many distinct factors for 72 exist whose HCF is two. HCF 1 means the numbers will become co-prime to each other. Take two factors from 72. Numbers should be distinct. 2 comma 2 we should not take. Whose HCF it is 2. Process remains the same. Very, very interesting questions, sir. Very, very interesting questions. Number is 72. 72 it is 2 power 3 into 3 square. Two numbers I need to pick, A and B, which is of the form 2 power x1 into 3 power y1, 2 power x2 into 3 power y2. HCF of A comma B it is 2. HCF of A comma B it is 2. So it is 2 power 1 into 3 power 0. It is 2 power 1 into 3 power 0. That means minimum value of x1 and x2. Minimum value of x1 and x2 it should be 1. That means if I give 1 to x1, I can give 1, 2, 3. Minimum it should be 1. 0 will not come. 0 if it comes, then the HCF will become 1. I hope it is 2 power 0 it is 1. Minimum I should give 1. x2 will be greater than or equivalent to x1. Lowest, right? 1 with 1, 1 with 2, 1 with 3. If x2 if it is 1, here it will be 1, 2, 3. 1 comma 1 we should not take. 3 plus 3, 6. 6 minus 1, 7. 7 cases, 6 minus 1, 5 cases. Totally 5 cases. I hope the idea it is clear. Is there any restriction on 3? No. So minimum of y1 and y2, it is 0. That means if y1 is 0, y2 can be 0, 1, 2. y1 0, 0, 1, 2. 5 cases. 5 5s are 25. One case will be where both are equal. 12, 12. So answer for this question is 12. Answer for this question is 12. I hope the idea it is clear. Generally, when you are solving mock questions, you take a lot of time to solve because you go by the formula-based learning. But once you understand the concept behind the question, visualization is the first step to make you understand the root cause of the problem. He is telling 72 is one number. In that one number, pick two numbers whose HCF it is 2. Pick two numbers whose HCF it is 2. I hope the idea it is clear. 1 1 1 2 1 3 1 1 1 2. Totally how many numbers we got? 12 numbers we got. Let us see whether if you count it also you will get 12 numbers. Suppose 2 with 4. Are you all with me? 2 with 6. 2 with 8. 2 with 10. 12. 2 with 18. 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers are already you got. 8 numbers, how many total numbers are there? Total numbers, how many we got? We got 12 numbers. That means 4 more numbers we have to take. What are that 4 numbers? Let us check. 4 with 6, 9 over. Next one. 4 with 18. 4 with 18, HCF it is 2. Next one. Suppose if you see here, 4 with which all numbers? 4 with 6 we took and 4 with 18 we took. 8 plus 2, 10 numbers. Next one, let us see if there is any other number. You can go by any other number. Why to check? Here you will get the approach very clearly. So what are the numbers? 2 power 1, 2 power 1, 2 power 1, 2 with 2. 2 power 1, 2 power 2. Are you all with me? 2 with 4, 2 with 8. Next one, 4 with 2. Okay, next we eliminated. 8 with 1. This is first case. So 5. 0, 1, 2. So here it will be 3 power 0, 3 power 0. 3 power 0, 3 power 1. Throw 3 power 1. Combine with this. I think all the cases you will get it. 2 more cases you can check it. I hope the idea it is clear. Very, very easy question. So 3 plus 3, 6, 6 plus 1. Right? 5. Anyway, this will become 5. Easily you can tell the answer 2. Why? Because HCF it is 2. HCF it is 2. 2 cube will go away. So 2 power 1 will go away. Remaining is 2 square. 2 square 5 cases. 3 square 5 cases. Now let us do one more last question. How many factors for distinct factors for 21,600 has HCF 45? How many distinct factors for 21,600 has HCF 45? First thing, whenever the number is a composite number, first write down the number as a power of prime basis. 216 into 100, 6 cube into 10 square. So 2 cube into 3 cube and 2 square into 5 square. So this will become 2 power 5 into 3 cube into 5 square. This is the number. 21,600 is 216 into 100. 216 is 6 cube, 100 is 10 square. 6 cube is 2 cube into 3 cube, 10 square it is 2 square into 5 square. 2 power 5, 3 cube and 5 square. Now, HCF it is 45. A we don't know, B we don't know, but HCF of A comma B. HCF of A comma B is 45. 45 it is 3 square into 5 power 1. Minimum power of 3 should be 2. Minimum power of 5 should be 1. So A, it is 2 power x1, 3 power y1, 5 power z1. I hope the idea it is clear. X2, 3 power y2, 5 power z2. 5 power z2. Is there any restriction on x1 and x2? No. 45 does not have power of 2. So definitely I will get 11 cases here. 11 cases. What are that 11 cases? If x1 is 0, x2 will be going from 0 to 5. If it is 0, this is from 0 to 5. 0, 0 is duplicated. Y1 and Y2, there is a restriction. minimum of y1 and y2. How much it should be? 2. So if y1 is 2, here it will be 2 comma 3. Here if it is 2, here it will be 2 comma 3. 3 cases I will get. Similarly, minimum of z1 and z2, it is 1. If z1, if it is 1, z2 it will be 1 comma 2. For 3 cases. So totally 11 into 3 into 3, 99 cases. 49 here, 49 here, 1. These both are eliminated. Answer is 14. Answer is 49. Very, very good question. Which this kind of questions, this kind of logics, you can refer any best aptitude series. Session 1, Session 2, Session 3, Session 4, Session 5. Every question is new question. Every question brings out a beautiful concept from aptitude. In case if you are somebody who is looking out for any of the aptitude courses, kindly download ANC app and you may check in the course section what are all the various courses are there. In case if you want to know more about the courses, you can always WhatsApp 80500678991, which is present on the video down. Do not hesitate to seek my mentoring for any kind of help. Thanks a lot for watching these special series. Thank you. With love, Anil Nair.